All right, all right, all right. Last preparations, and this is it. Ladies and gentlemen, I'm so excited to actually open this event, this great software architecture global summit by Geekle AI edition 2025. I'm Ed Nedian, CEO and founder at Geekle, and I'm finishing my matcha on cocoa milk, and I am so excited to see my audience here. Let's just say hello each other in our chat, and as always, this is our tradition. We always say where we are from, where we base now. I'm in France, in Nice, and just let me know where are you, just to encourage me and other speakers to uh, know you are here. We have an audience, we have someone watching us, and we're we're about to start. We're about to start. Let me see what I have from our technical support here. I have my Greek coffee with me. Oh yeah, cool. Greek coffee. I wish I had it. Let's go. First, I want to share what's gonna be like the structure of this day. Software Architecture Summit this time is structured in two parts. First is today. The day is focused overall on architecture. So we're talking about different aspects of software architecture, not focused on AI. But tomorrow, we're going to discuss everything, what's new and what happens in the field uh, with AI tools and everything. I know what you sorry, I know you know what I mean. So um, today we're gonna be listening and diving deep into following topics. Your architecture is a crime scene. Why that? I don't know. It's so nice to hear what that means. Out with the old, in with new. It's the next topic, a guide to application upkeep. Okay. Scaling IOs with reactive architecture, then data governance in a Medallion world. Don't know what it means, and I would love to know more. Driving ROI through automation, then augmenting architecture designed with AI. I mean, really, we already can augment something with AI or what? Architecting lightweight mobile experiences sounds familiar, and leveraging Gen AI for customer support. Well, I was wrong. We have enough AI even today, and that's probably great. So three blocks, three Q&A sessions for today, same for tomorrow for AI Day. And if you don't have any ticket for tomorrow for AI Day, just use this discount live. It will give you the discount actually for those who present today for tomorrow's day. Let me now see what we have in chat. Still don't have too much um, cities over there, and we are moving on. I'm not sure if it works. We need to check it out. Normally, we have much more, and then we go for announcements for the AI Day. So topics on AI Day are local development, serverless production. Okay, monitoring business metrics, catch downtime. Nice. Implementing an enterprise data bus. Well, I heard something about that. Ephemeral Jenkins with AWS. Okay, great. Generative AI, an innovative companion for software architects. Companion. I love this word actually much more than copilot or augmenting or whatever. Proactive Gen AI tools for software architecture. Proactive. Hallelujah. Finally, something will work. Um, even proactively. Scaling and optimizing enterprise app. Nice. Why Yagni matters in software architecture. Okay. Model Context Protocol, MCP. Buzzwords are here. Why is this a game changer in building intelligence applications? That's what we are expecting for tomorrow. And let me just real quick type this navigator. Let me share our latest storage uh, for all recordings. Yeah, here we go, and let me pull it up. Yeah, you can see it now. It's our new storage for videos. You can navigate over here and pick software architecture, and you can see previous event all here. And these recordings will be something like 1 week after this event over. Also here. And yes, the next step, like like we're in train, CTO Global Summit. I want to share it with you too because it's something unusual for us. Well, for years, software architecture summit was the kind of the most high ranked um, event at Geekle, but now we're moving to CTO Global Summit. Agentic SDLC will be discussing AI transformation in SDLC in two directions. One is developer productivity, all these AI tools and metrics and stuff, and the second direction is AI in products, where we'll be exploring what is ongoing experience with implementing AI in different products. We expect more than 1,000 CTOs here, more than 100 AI startups and dev tools will be competing for best voices and appreciation from the audience and also speakers. And this is something unusual. Uh, I have more than 200 applications to speak at this event, but I'm interviewing everyone personally just to make sure that these guys have some nice real life stories, not just opinions and ideas about AI, but people who tried something or hardly work into AI space. And they have stories you can learn from. So please pay attention to this event. And it's not just an event. This is Summit with 5 chapters. On June 12th, we'll have pre-summit. Will be just overview whole area of using AI in SDLC. Then we'll have September, October, November, and December chapters where we will be diving real deep in very specific use cases of um, how people use AI, how people leverage it, both again for developer productivity in dev tools and AI based products. So if you are a manager, if you want to learn more about somebody's AI transformation experience from different companies, different domains across all countries, uh, go to our CTO Global Summit website and apply. And this is invitation only. You can't just go there and buy it. We need to make sure that audience is relevant and only managers are there. And this is the networking everyone will be happy with. All right, so now I guess this is it. We need to move to our first topic. Um, we have some great time today, and I can't wait to actually invite our first speaker to this stage. Manfred Steyer, your architecture is a crime scene. Oh my God, that's scary, Manfred. What's going on? What you invented, man?
Yeah, so this metaphor is borrowed from a book I have read last year,
All right.
and it was published in the second edition. And it shows that you can use ideas from investigating crimes also for finding out about the quality of your source code. And you can aggregate this on an architectural level. And at the end of the day, this is a nice alternative to traditional code analysis.
Jeez, man, that's cool, actually. Manfred Steyer, ladies and gentlemen, is here with his presentation. Thank you for joining. Thank you for being ready to share your energy and expertise. And let me pull your slides over here. Now we have, yeah, yeah, it's good. And the stage is yours, Manfred. I'm here around, so if you need me, just call me, okay?
Awesome. So thanks for having me. I want to get started with a simple tiny code example with this one here. We have here a snippet on the left side and a snippet on the right side. So my question is, what do you think? Which side is more complex? I think most people will say the right side is more complex because the left side is obviously a nice switch case. So we see at first glance what's going on there. When it comes to the right side, honestly, I'm using this slide now for half a year and I still did not find out what's going on there. So I think most people would really say the right side is more complex. However, if you use a traditional way to measure the complexity, like cyclomatic complexity, which is implemented in all the quality tools out there, then you find out you have exactly the same cyclomatic complexity of both sides. The cyclomatic complexity is measuring how much paths you have going through your source code. Or to put it in a simpler way, it is counting the ifs, the fors, the whiles, the switch cases, and so on. And because of this, we have a complexity of 4 on both sides. I think this already shows that the cyclomatic complexity has its limitations. And very likely, if you have dealt with something like this, you also had this in your guts. Your gut feeling already told you that this cannot be the last word on this. Perhaps you say now, yeah, Manfred, but this is the cyclomatic complexity. There are other ways to measure the complexity. Perhaps they are better. And my elaborated answer to this is no. No, they are not better. And meanwhile, there is a nice study showing this. This study was done during the pandemic. And within this study, they put a lot of software developers into a tube, into an fMRI and functional MRI. And in there, in this tube, they got some source code to read and questions about the source code. And then when they tried to answer those questions, they measured the brain activity. And so they compared the complexity that was measured there in terms of brain activity with the complexity we get out of complexity measures like cyclomatic complexity, but also other alternatives. And what they found out was quite funny. They found out that complexity measures like cyclomatic complexity are measuring quite a lot, but complexity. Or to put it in a more scientific way, the correlation between the measured complexity in the MRI and the calculated complexity was low to average at best. And one more time, I think this is baking something we already had in our guts feeling, namely that those metrics cannot be the last word on this. So now, as we know that this is not that great, let's switch the perspective. Let's think about something we really want to know when we want to find out whether our architecture is good or not, whether our architecture helps us to stay maintainable in the long term, for instance. Well, when it comes to this question, what we usually want to have is a verticalization. We want to subdivide a huge application into vertical parts that don't know much about each other, because we want to change something here without breaking something there. Usually within those verticals, we have features and other stuff going together. They are somehow connected to each other because the code in there needs to work together to achieve a joint goal. But between those verticals, we want to minimize the dependencies. You can also put this in a more technical way. You could say, well, inside of the verticals, we want to have a high cohesion, more connections, because stuff needs to work together. But between them, we want to have a low coupling. And this leads to some interesting characteristics, like getting a single responsibility per vertical. Of course, this is here a more coarse-grained single responsibility, not as fine-grained as on a functional level or on the class level. But nevertheless, there is one common theme, one common area where we try to provide business value to the user. Also, most changes will now be isolated in one vertical, which is great, because in order to change something, you should not load the whole system into your brain. Your brain, your main memory, is obviously limited, and the whole system might not fit there. So it's nice to have one change isolated in one smaller aspect of the overarching system. This allows you to change the stuff without a lot of bugs and without influencing too many other parts of the system. This is also reducing cognitive load because, as mentioned, our main memory is limited. And when it comes to cognitive load, meanwhile, we have a lot of studies showing that cognitive load really correlates with the quality we are even able to produce. Another thing we get here out of this is more or less a correlation with Conway's law. Conway, back then in the late 60s, found out that the structure of our application is always a mirror to the structure of the organization where the application is built. Or to put it in a shorter way with more modern terms, your architecture always follows your organization. And there is a simple way to explain it. Namely, let's imagine you build a compiler. You build a compiler with 3 teams. What you will end up with is a compiler working in 3 phases. Each of those teams will work on one of the phases. Because usually a team member is talking more to members of its very own team and less to other team members. And so more or less naturally, this compiler will be structured around 3 phases. So we cannot really avoid Conway's law, even though it's not a law of nature, it's more of an observation. So what we try nowadays to make sense of this, to utilize this law, is to structure the teams in the same way, more or less, we want our architecture to be. And this now makes it easy to get the architecture we have envisioned. Sometimes this is mentioned the inverse Conway's maneuver. We are turning this around so that we get the architecture by structuring our teams. So as you see here, this leads to a lot of nice characteristics for maintainability. Plus, you can measure low coupling and high cohesion. Just measure the amount of connections, divide it through the maximum possible amount of connections, and you have a nice ratio. There is another thing that correlates a lot with the quality we are able to produce, namely code churn. Meanwhile, there are also a lot of studies around this. When it comes to code churn, we measure how many changes we made to a specific area of our source code, to a specific file or to a specific module, vertical, business domain, whatever. And it turns out that the amount of changes tells us a lot about possible issues in there. Just imagine you have a file and this file was changed 50 times in the last 3 weeks. This is for sure an indicator that something wrong is going on there. Of course, in the beginning of a project, you will have a higher code churn, but usually this is stabilizing during the iterations. This book here that was released last spring in its second edition is taking all those ideas, the ideas of Conway's law and inverse Conway's maneuver, the ideas of verticals, the idea of code churn. And it brings it together to a new way for analyzing your source code and your architecture. This book has been written by this young gentleman here, Adam Dornhill, who is a scientist researching in the area of code quality. And what he did is really funny. He cloned a lot of huge projects from GitHub, projects done by big companies like Facebook, by Google, by Microsoft, by SAP, and so on. You'll find all the big names in there. And he analyzed the source code. And then he compared his results to things like issues in specific areas of the source code. Of course, we can easily find out about issues just by looking at the reported issues on GitHub, for instance. By the way, Adam Dornhill has also a history in criminal forensics. And he is using a lot of metaphors from this area. For instance, he is saying, when you investigate a murder, you not only look at what you have now, at that body in front of you. No, you are also looking at what happened around this murder. Who might be a suspect and where could the suspect have been during the time of the murder? Was it even possible for them to get to the crime scene at the right place to conduct the murder? He's using exactly those ideas to also analyze your source code. And for this, he's not only looking at your source code, that body in front of you, he is also looking at everything that happened around it. And funnily, this everything is nicely documented meanwhile in your source code history, for instance, in your Git history. So we have all this information. We just need to utilize it to find hidden patterns. And this is what he is doing with the so-called forensic analysis. It is unveiling hidden patterns. And trust me, it is really awesome to see your code base, a code base you work on a daily basis from this perspective. Because suddenly you see your daily work from a completely different perspective. And so you might find out, well, this is really an issue. I have never thought about this. Perhaps you say, yeah, this is theoretically an issue here, but practically this is fine. It's a deliberate decision. Then it's also fine. So it's not about finger pointing at your work. It's just about a switch in your perspective to find out things that might be an issue, that might need some love. And this is the agenda of this presentation here. I want to show you two tools for a forensic analysis. I do a simple demonstration using one of those tools. And then I want to show you the limitations of the forensic analysis, because no silver bullets here. I'm quite amazed about this, but I think we all should be aware of the limitations, of the overarching picture, of the overarching mosaic. The forensic analysis is just one stone off. Before we start, let me introduce myself. I'm Manfred. I'm a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. In this role, I and my colleagues are helping a lot of companies with trainings, with consulting, with reviews and development. I'm quite connected to the Angular community. I live in Austria. I do a lot of stuff in Germany. Since 2008, I'm in Germany every second week, traveling across the federal countries, helping companies with architecture, with Angular, and stuff like this. And I'm always happy to work to people around the globe. For instance, last week I was in France. Okay, so let's get started talking about tools. There is one tool that is called CodeScene, which is the gold standard in this area. And perhaps the name rings a bell. CodeScene sounds similar to the name of the book, Your Code as a Crime Scene. And this is not a coincidence, because this here is the official tool written by the master himself, by Adam Thornhill, who also wrote this book as a nice summary of the results of his studies. So it's more or less applied science if you use this tool here. It's free for open source projects, so you can easily try it out. And you need a license for commercial projects. It provides a lot of analysis methods, and it has an awesome visualization. Also, manager-friendly visualization that allows you to convince your manager that you need a refactoring here or there. It provides several programming languages, all the possible programming languages. I think if you're not implementing your code in assembly, Thornhill got you covered. And it works on a code level, but it's also capable of aggregating the findings on an architectural level. And here you'll find more information on this. So this is the gold standard. Besides this, as I was so amazed of those ideas in this book, I also implemented an own solution for this. It's my take on forensic analysis. It's open source. It's called Detective, as you see here. It's limited to a few methods, and it is aggregating everything on an architectural level, because this is what I need in my daily work when I'm helping other companies with architecture. My idea was I need to have a quick way to get a good overview of the architecture in there. It primarily works for TypeScript. And if I say primarily, I mean only. So it's currently TypeScript only. It is directly using the TypeScript compiler API. And as mentioned, my focus is helping myself and my colleagues in reviews, providing a little tiny mosaic stone within the overarching review process that helps there. And it's not an alternative to CodeScene. No, I see it more as an appetizer for CodeScene, something we can quickly spin off to get an idea of what's possible there. And for this, I've prepared a little tiny demonstration. So let me start Detective here. So first of all, what we see here is my modules. My modules are defined by folders. I can check those folders here so that Detective knows which folder is a module. And then here I see the connection between those folders. I can even drill it down to the level of my layers. And here we see, well, as mentioned in the theory, we have two different business domains, two different verticals. They are not coupled to each other. That means they can evolve separately, but in there, they are working together somehow. So at first glance, this works quite nicely. Of course, we could discuss if one feature should be allowed to access another feature, because if this is allowed, the second feature can also access the first one, and so you end up with a cycle. Yeah, but this is something you can discuss. Perhaps you say, yeah, I need it, or perhaps you say, okay, let's refactor this or that way so that we don't run into an issue like this. So this here is nice, but this here has nothing to do with a forensic analysis. It's just an analysis of imports. But now let's switch over to our first forensic analysis, which is change coupling. So change coupling tells us which parts of the system have been changed together. And here we see, for one reason, a feature from ticketing has quite often been changed together with a feature from check-in. We find the source code for this in the same commits. And this is a sign of hidden coupling. Perhaps we don't even see this kind of coupling in the source code, but it's there. For some reason, every time we change something here, we need to think that we also need to change something there. Hidden coupling. Perhaps this is because your verticals are not structured in a nice way. Perhaps you should rethink about structuring your verticals. Perhaps you have duplicated code, and that's why every time you change something here, you also need to change something there. By the way, when doing a forensic analysis, you usually limit the analysis to a given amount of commits or to a given time frame. The last 12 months, for instance. Here we have a hotspot analysis. The hotspot analysis is subdividing all your domains, your verticals and layers like ticketing and feature booking to areas. Green areas where everything is fine, yellow areas where you have a warning, and red areas with an issue. And if we look into the red areas, we see there is a hotspot score calculated. The higher the complexity of the files in there and the higher the code churn, the more changes we did to the source code, the higher the hotspot score. Which correlates perfectly with what I've told you before, that a high code churn is an indicator, and there is a lot of study out there that we have an issue in there. At least if we have a high code churn in a given amount of time, like the last 12 months. Of course, if you say, well, 2 commits is not an issue for you, then you can increase the tolerance here. This is like in Photoshop. The higher the tolerance, the more green areas you have. The lower the tolerance, the more red and yellow areas you have. And this here is also a nice way to communicate technical debt to your manager. Because now the manager sees, well, not everything is bad, but there are some areas that need love. And if you want to convince your manager, tell them that according to Thornhill studies, implementing a new feature in the red areas takes twice as long. That means if your manager thought they have 10 people sitting around, when it comes to the red areas, they only have 5 people because it takes twice as long. And this is something also a non-technical manager understands, that you need to do something there, because subdividing their teams in 2 by the half is really hurting them. Here we have the team alignment. Let's go back to the domains. And here you see that everything has been done by one team, a team called unknown. And team unknown is my lesser self. This is because this example has been written by my lesser self. But to make it a bit more exciting, let's restart this in demonstration mode. And now I'm squeezing in some Epidary users, Git users in my statistics. By the way, to get those team alignments, we see now we have an example team A, B, and unknown. And teams are just defined by mapping Git usernames to team names. And here you see you don't have a perfect alignment. The orange team did a lot of stuff here in the check-in domain, but also another team had to do a lot of stuff. And we have the same situation there. The purple team did a lot of stuff there, but also the orange team had to implement stuff. And this might invite you to a discussion about the team alignment. Perhaps you need to rethink one more time the boundaries between your verticals, or perhaps you have a nice team structure on paper, but no one is following it. By the way, if you break this down to the user, you see the drug factor. For instance, here, Max Muster, the German John Doe, did about 78% in the last 1,000 commits in this vertical check-in. That means if Max Muster is leaving the company, you really have an issue. You lose a lot of knowledge. So before I come to the end, let me quickly show you what are the limitations of this nice approach. Well, the thing is, a forensic analysis is not a replacement for other things you do in order to make sure your architecture has quality. It's not a replacement for code reviews, for workthroughs, for developer interviews or stakeholder interviews in general. It's not an alternative for knowing your architectural goals, respecting best practices, and define them with few to consequences, conscious trade-offs, and to get some advice. However, it's another stone in this mosaic, another stone that allows you to get some additional good questions for interviews with your developers. Not more and not less. However, if this allows you to come up with 3 additional good questions, you also won a lot. So let me come to a conclusion. What did we see today? We have seen that we can unveil hidden patterns using a forensic analysis. We can analyze change coupling, which files change together. This is a hidden kind of coupling we might not even be aware of. We can visualize hotspots to find out where in the source code we have areas that need some love. And we can find out about the team alignment. We can find out whether we are following Conway's law if one team can fully concentrate on one vertical. And this is the invitation to some good discussions, because out of this we get some good questions for those discussions. And that's it. I've already uploaded my material to my blog. You find everything there. You also find some information there about how run detective in your source space, and follow me on social media to stay in contact. Thank you.
And yes, thank you very much for your presentation, Manfred. Now I understand more why it's a crime scene, because you guys even have this MRI thing. So as normal crime scenes do, actually, they have also this medical care about that. So
Yeah, it's like tech stuff for code, for source code.
yeah, so you were trying
Forensic expert.
to get inside of human brains to see what's going on. Thank you very much for this great presentation, and let's catch up 1 hour later for questions if you can.
Sure. See you around. Looking forward.
Yeah, thank you very much. All right, ladies and gentlemen, we're moving on to our second speaker, and let me introduce Andres Sacco, great speaker and the friend of Geekle, the big friend of Geekle, with the topic "Out with the Old, In with New: A Guide to Application Upkeep." Let's go.
Hello and welcome to this talk. And perhaps the title sounds too long for you or funny at the same time. But the problem behind the scenes, it's complex for most of the developers. But first, let me introduce me. My name is Andres Sacco. I work as developer since 2007 using different technologies like Java, Kotlin, Scala, PHP, Node.js, and many others. I participate as technical reviewer on some of the biggest editorials around the world. The idea is that the editorials or the publishers send me a chapter or an entire book. I read it, I do corrections. The idea is improve the quality before that will be published. I wrote some books and I create some theoretical practical scenarios. Some of them appear on the presentation. and I participate as a speaker on different conferences. You have my contact information on the slide, my LinkedIn, my email. So if you have any doubts, any question about this talk or other topics, just contact me. I will try to help you as soon as possible. Okay, let me start with the context of our situation. So you have at some point some legacy applications. Perhaps you work in a company and there are many microservices that are too old and using old versions of Java or .NET. And at some point, it's a problem. And why? Well, first one, most of the libraries not support too old versions of Java. In this case, I reduced the scope to Java, but happened the same with C# or .NET or Kotlin or Scala. Each application could use different versions of Java or other languages. So perhaps you have, I don't know, 10 microservices and each of them use different versions. So it's complex to update all of them to the same version of Java or Kotlin. You could apply different solutions to solve the same problem. Imagine that you detect problems and to parse the HTTP request and do something, and you fix it on one application. But this application uses a specific version. So when you try to copy and paste this solution to another application, most of the features or the improvements not work because this other API don't use the same version. So this implies that you spend more time creating the same solution on each different version of the programming language. It's difficult to know if a library have new versions. It's not just I work with a legacy application. Imagine that you create an application from zero, but at some point it's difficult for you detect or analyze which libraries have a new version that fix some problems or improve the performance. You need to do manually each time. And it's difficult to improve the performance. If you use an old version of a programming language, perhaps have some problems related with the use of resources like the memory and the CPU and many other things. Okay, let me show you an example to represent all these things. So you have different microservices. Each of them have different versions of Java. So the first one, it's API A and use Java 8 and use the code style of Java 8 and use an old version of Spring Boot. Okay, that is not a problem. But on the same company, you have a microservices B, and these microservices use Java 11, but with the feature of Java 8, and use another version of Spring Boot. Here we have a problem. Okay, well, two different versions of Java, two different versions of this framework. Could be a problem, could be a not. API C, Java 17, and Spring Boot 3. So, okay, this is not cool. You have three different versions of Java, three different versions of this framework, so the solutions are not compatible. Could be worse. Oh, yes, could be not the best scenario. So you have 4 different microservices, 4 different versions of Java, and 4 different versions of Spring Boot, this framework that it's popular to create microservices, to expose endpoints, and do many things in a simple way. So at this point, if you need to do some improvements related with the performance, you need to create 4 different solutions. And while this could be relevant to us to keep updated, well, there are many reasons to do that. The first one is stay protected about vulnerabilities. Perhaps when you create a microservices from zero, you use some version of a library or a dependency, and everything is great. But after some months or years, someone detects a vulnerability. So you need to reduce this security risk. And the best way to do is improve or update the version of that library. Of course, you benefit or you have the benefit of improvement related with the performance. In the case of Java, each new version that appears reduce the use of the resources on many aspects, on the CPU, on the memory, on the process things, and many other things. And when you have a new version of a language like Java, you can use different new libraries. If you use a very, very old version of Java, perhaps most of the libraries that exist are not supported. So you need to do everything manually. You need to create everything from zero, like a craftsman. And it's a way to ensure that the tools that you use, for example, I don't know, Sonar or many other things, have support to push the results or to analyze the code or many other things. And okay, which alternative exists? So, well, this depends of the language, but in the case of Java or the JVM ecosystem, there are many. The first one is do manually. You can update the code, you can check on the repository, in this case on the Maven repository, which is the latest version of one particular library. This implies that you takes a lot of time because you need to do it library by library or dependency by dependency, and you need to do frequently. It's not like, I do at the beginning of the year and I will do again at the end of the year. No, because in the middle of the year or each month appear new version. It's not possible that you wait 1 year to update your project or your microservices. Could be the worst scenario. Okay, this is one alternative. The other one is automatically delegate to a tool or something the job to update the dependencies and change the source. So it's like, okay, find my dependencies, find the new version and update, but just the dependencies, the number of the version of that dependency, and nothing more. And in the case that you need to do a big update, which is the worst scenario, or this occurs in most of the cases when you have a legacy application or an application that no one's update for a long period of time. This could happen, but you need to use some tool or library or something that do all these things for you. It's like take the old source code and translate to a new version of Java. For example, from Java 11 to the latest version of Java, many things changes on the syntax, and the same happen on C# or Kotlin or Scala. This situation appears on many languages. Okay, which tool exists to do it? Well, there are a series of tools. The first one is Renovate, and Renovate it's a great tool because detect the problems and generate to you the merge request related with the dependencies, analyze the code and detect on the file that you define the different versions of the library and create for you a merge request. This tool is agnostic to the language, so you can use on many languages. It's like a plugin on GitLab or GitHub, but you need to pay, or the best version of this library is that you need to pay. There is a possibility to use open source, but you need to run locally or in a services, and you need to configure many things. It's not simple. The other alternative is Rewrite, which is an open source solution that support many languages like C#, .NET, Java, Kotlin, Scala, and many others. There are some plugins in the case of Java, Gradle version in the case that you use Gradle, like as your dependency management tool, and Dependabot. This is another plugin that you could install in your CI/CD or in your GitHub or GitLab and create for you the merge request. Okay, let me explain what are the main difference or a comparative between all these alternatives. Well, all of them have a great documentation, are excellent, have a very detailed explanation about how you can install, you can use, and the trade-off that you need to consider when you select one of these alternatives. Support many languages. Here appear the main problem. It's all of them support many languages. In the case of the Maven plugin, it's only work on the Java projects or Groovy projects or Kotlin project. It's more or less related with the JVM. It's not possible to use, I don't know, use with Python, for example, or PHP. Which of them refactor the code? It's like, okay, I have an old version of C#. I need to update to the latest version. And the unique tool that do this for us is OpenRewrite. The other ones only update the dependency version and nothing more. Show you, okay, this dependency have a new version and this one is the new one. You want that I update for you, it's okay. But if appear a new feature that improve the performance for us related with the language, these other tools not do for us. Automate dependencies, well, in the case of Renovate and Dependabot have the same approach, create merge request for us, and with the new version of the different tools. Both tools generate for us a merge or pull request, and so you only need to accept the merge request. And perhaps if you have integration tests or other things in your pipeline, could be great, because when this new pull request or merge request appears on your application, will run the entire pipeline and verify that everything continue working. Because one thing is update the version of a library, and another one is that the application continue working. There are two different things that you need to consider. And all of them have a great community, or a big community of users. There are tons of different articles appear in some books, or there are talks about these specific tools, all of them. And here, the winner in our case, because we need to remove the old code and put or recreate the API or do modifications, it's of course OpenRewrite. Okay, all of them solve most of the problems, but in our case, OpenRewrite have the following features. Have recipes to update the application with new versions. Define a series of steps, like, okay, if you have this code to migrate to Java, I don't know, 21, you need to do these kind of things. Or this way to declare a variable on the old versions, now you could translate to this one. It's like more or less a different kind of recipes, because it's not just related with, I don't know, with the language. You can update the version of your framework or the way that you do different things, but you need to choose in a catalog that have many recipes, each of them for a specific purpose. Make change incrementally to minimize the disruptions, like, okay, if I do from Java 5, for example, to Java 21, perhaps most of the things will fail because there is a big number of changes or improvements from these two versions. So it's possible to say, okay, I want to update or upgrade my application from 5 to 11, and after that from 11 to 17, and from 70 to 21. It's more or less, you can do more steps to do the migration, but it's more safe. It's possible to run locally or in a pipeline. It's just a plugin, so it's possible to do on many places. It's not like, oh no, you need to do in a specific server or in a pipeline. It's not possible that you check if everything works locally. Analyze the code and detect if this code has some kind of problems related with the import, with the structure, or the way that you declare, and try to fix it at the same time. And this helps, as I mentioned, to upgrade, for example, Java versions from 8 to 21, or frameworks. There are a long list of frameworks that are supported, and it's open source and have support to many languages, as I mentioned. And this contains the link to access to the web page. What implies OpenRewrite for us? Well, the first one, everything it's okay, but you need to learn the code to understand the recipes. What is the idea of this recipe? What do behind the scenes? It's not like, okay, I put the library, run, and everything continue working. No, you need to analyze, understand what changes these recipes do for us. Modify the configuration on the dependency management in the case of Java applications. Do modification in the pipeline in the case that you want to run on a pipeline, and validate the changes. Run your application and check if everything works or not. And here you can find the code that I will use during this presentation. So here is my repository. And in this repository, I have an explanation about the requirements, the version of Java, the version of Git, and many things that you need to have in your machine in the case that you want to run your application, or this application. In this case, I have one application, one API that have Java 17 and use a version of Spring, which is not the latest. Is not a too old version, but it's not the latest. So what we can do with this? Okay, the first thing that I could do, here is the application. I will open my POM file, and I will show you what happened with this plugin related with Maven. So I will add here the plugin related with Maven, which give me some information about the versions. So I will run. Let me check if this load the plugins or not. Before to do it, Maven versions here. Okay, let me show you. The first thing that I could do is display the dependencies that I need to update. So I run this command. This command will download all the dependencies and will show me some information about, okay, here. You have all this information about which things I need to update, okay? There is a new version of Data Faker or Instancio, MapStruct, Mockito, Spring Boot, and many other things. Okay, you have information about this. But perhaps these dependencies, this one, or another one, could be transitive. It's not my responsibility that I use an old version. So I could say, okay, show me the information, because here I define a series of properties with the different version numbers. So I will say, okay, show me the information about these properties that I define. Which of them I need to update? So here I have an explanation. All these things you need to update, you need to change. It's great, but you need to do manually. You need to enter and one by one and change the number of versions. Okay, it's a great alternative if you don't have anything that do automatically for you. But if I use this version of Java, I can increment the number of versions, but I will not use any new feature or improvement from the language. So what I could do? Well, let me show the web page of OpenRewrite. Here you have all the language that are supported. You have C#, .NET, Groovy, Java, as I mentioned, Kotlin, Node.js, Scala, and well, this one, SQL, and many others. In the case, I don't know, imagine that you want to improve the version or something related with Java. Here you have all the tools that are supported. In my case, for example, Spring Boot. And here you have the list of categories that have a recipe to do this updated on your application. In my case, I have these different recipes to migrate to Spring Boot 2.3, 3.4, 3.5. Okay, here you will find all the information. Let me show you what implied in my application. As you see, I add a plugin here that gives me information from the versions. I will add another one, this one. This depends of the language, so consider and your dependency management, so could be not the same. In my case, I use this version, and here I declare the list of recipes that I will use here. In my case, I will say, okay, order the imports, change the order of the imports that could be in a bad way, upgrade my application to Java 21, and upgrade my Spring Boot version to 3.3. And here I need to declare where exist these recipes. In my case, the recipes connected with Spring Boot live in this dependency, and in the case of Java, these two reside in this plugin. Let me reload everything again. Okay, and here appear rewrite. So let me show you, in the case that you want to check if this work and if I execute the migration, nothing throw an exception, you can do a dry run. It's like a simulation. So in my case, I execute a dry run, and this more or less show all the things that will modify. Here more or less show you the list of recipes, not paying attention to this warning. Okay, this more or less 20. This is the estimation of the time that you save it, and say, okay, if you want to do a migration from these microservices or this application, please execute this command. I have this command here. I will execute from IntelliJ. It's the same you can do from the console. And this will take some seconds or minutes, depending on the complexity of your application, the number of classes, and the number of recipes that you activate on your application. Okay, a lot of changes will do. Let me open a console and check what happened with this. Okay, there are many changes. All these things are changed from my main branch. So if I do a git diff, you will see the changes. Okay, update the version to the latest version of Spring. Let me see. Change the version of Java. Change the version of OpenAI. Change the version of the compiler. Remove some things that appear on the POM files. And well, this one are my changes. And many other changes related with the optimization of the POM file. The POM file is the file that contains all the dependencies. And look this. Remove some annotations which are not necessary perhaps in the new version of Spring Boot or are implicit. So do the corrections for me. And remove, and this one is the declaration of the OpenAI specification and the annotations. So change to the new format. It's the same, but look this. I declared the example using an old format of Java and change to text blocks. This one is text blocks. It's a new feature of Java. So detect that I use an old version or an old way to do it and say, okay, here is the new version. So all the things do for you. Here appear a new way or a equivalent way to do this line. And all this modification do for us. You don't need to do nothing. It's just add the plugin and check if everything is okay or not. Look, a lot of changes and included my unit test. So let me summarize this talk. Some best practices about this one. The first one, combine a tool. It's not just use Dependabot or OpenRewrite or anything else. No, you need to do many things. Maven tool or the Maven dependency tool, it's a great idea to detect changes or that a new version of a library appears. It's great, but in the case that you need to do a biggest update from a legacy application, perhaps OpenRewrite it's a good alternative or a good idea to use. Change the libraries that perhaps not work with the new version of Java. Perhaps some libraries not have support, and the recipe could fail during the migration. Use predefined recipes. There are a huge catalog on the official website about different recipes to use. Test the recipes locally using dry run, and after that execute the rewrite of the entire microservices, check if everything works or not, and after that push your code. And monitor the vulnerabilities. Try to use some tool that detect that there is a vulnerability, that there is a new version, that it's urgent, that you need to update. Perhaps you can use other tools, I don't know, dependency track or dependency check to detect these kind of things, or Sneak in the case that you want to use a pay tool. Some additional resources that you can use to understand the evolutions or why this upgrade or update about the microservices is so relevant, and some blogs. And thank you for assist to this talk, and bye.
Sorry, I was muted. Thank you very much, Andres, and thank you very much for this specific talk. As always, great, and well, migration is something. Let's move on. Let's move to our next speaker, Rutul Desai, scaling iOS with reactive architecture. Let's go.
Hello everyone, I'm Rutul Desai. I'm currently an iOS engineer with a strong background in mobile architecture. My experience spans several domains, including finance, where I led iOS architecture transformation initiatives at Capital One. Today, I want to walk you through the journey of scaling iOS using reactive architecture, the real world challenges we face, and the principles that help us build resilient, scalable apps. Let me share a bit about my background. I have spent the last several years leading mobile engineering initiatives at Kunai, where we have partnered with major financial clients like Capital One. This experiences shaped my perspective on scalable architecture and user experience. I believe deeply in systems that are resilient yet flexible, code that enables designers and engineers to move fast without sacrificing quality or user trust. Imagine opening your banking app after a deposit and not seeing the updated balance instantly. How frustrating would that be? That exact moment is where reactive architecture shines. iOS development has evolved dramatically. The evolution is quite dramatic in terms of the scale and size and how it has evolved. MVC was the default, but it resulted in massive view controllers. Later on, MVVM helped by separating business logic. Viper brought better modularization, clean architecture emphasized separation of concerns and testability. Now, reactive architecture helps us manage complexity and asynchronous data flows in a scalable way. So, what makes scaling iOS applications difficult? At Capital One, our flagship mobile app served millions, but as features grew, so did our problems. Monolithic code base is made ownership hard. Asynchronous operations like network calls or animations were scattered and error prone. Testing was complex and deployments pipelines slowed. We needed an architecture that could scale teams and code bases. Let me define what our reactive architecture is. It isn't about just reactive programming. It's about design systems that stay responsive under load, recover gracefully, scale predictably, and handle data as streams of messages. On iOS, we achieve this through reactive programming frameworks like Combine and RX Swift, supported by architectural best practices. There are many reasons why you would select reactive programming to scale iOS implications. So it flips how we think about app logic. Instead of pushing data through imperative code, we describe how the UI should react to streams of state over time. It's more predictable than it's fragile. This leads to code that's more easier to reason about. Flows, often the bane of mobile developers, are now first-class citizens, compete with composability and error handling. So, ever hit a bug because two async calls updated the UI out of order? Reactive architecture helps eliminate that kind of chaos. I'll put forward a case study that I came through using my professional experience. At Capital One, we were tasked with building a mobile app that millions relied on daily to manage their finances. The demands were high, real time transactions, feed, instant alerts, personalized offers, and most critically, trust. A laggy app erodes user confidence, so performance and reliability weren't optional, they were foundational. This is like building the cockpit dashboard of an airport. You can't afford misleading or lagging information. So here's what we are aim to support: military grade security protocols, offline capabilities that ensured users could check balances in airplane mode, real-time notifications that reflected instantly in the app, and a streamlined onboarding experience that felt seamless. Each of these had major architectural implications, and reactive principles helped us deliver. Picture a user trying to sign up during a subway ride. Offline first capabilities ensured that onboarding didn't break midway. So the solution centered around streams, that is, transactions, balances, and offers, and alerts flowed as continuous data streams. We built logic around combined publishers that handle network and persistent layers reactively. Even in spotty network conditions, users could interact with a responsive UI that synced as soon as connectivity returned. Think of your app like a stock ticker. You don't want yesterday's prices, you want now. These are the principles that drove our architecture. Unidirectional data flow eliminates state ambiguity. Imagine if your GPS shows three different locations because every component had its own state. That's what happens without unidirectional flow. We clearly separated business logic from UI logic. We leveraged declarative UI with Swift UI. Observability tools helped us track state and performance in real time. And finally, error handling was first class, not an afterthought. Reactive data flow is how the data flowed in the architecture. The backends emitted state changes via sockets or APIs. This fed into combined pipelines. View models transformed the raw data into view-friendly formats. Swift UI views observed this and reacted automatically. This pipeline reduced complexity, decoupled responsibilities, and made the UI feel alive. It's like a restaurant kitchen passing prepared dishes to waiters. Each part of the system only worries about its own role. So reactive MVVM on iOS works in was the go-to pattern for us. Each screen had a view model exposing publishers like transaction list, user status, or error state. The views simply subscribe to these, and updates were automatically. No imperative UI updates. This made it trivial to test, scale, and refactor components as the app grew. This is a practical snippet that we used. The transaction publisher emits whenever transactions change. We were on the main thread updating the UI. There's no need to store state flags or track dependencies. This declarative style reduces bugs and improves developer velocity. Here we blend combine with Swift async await. It allows us to suspend execution until we get a valid balance. This fusion of reactive and structured concurrency gives us the best of both: clean syntax and responsive, stream-aware behavior. By going reactive, we delivered measurable outcomes, performance improved, users felt that they could trust the app's speed and accuracy, and our engineering team was able to build and test new features more quickly. We also saw a noticeable lift in App Store ratings. The segregation of responsibilities and defined modules help engineering teams to perform better at their work. Developer burnout went down. Of course, no approach is without challenges. Reactive code can get complex if overdone. Over engineering was a real risk, especially when junior devs tried to overuse Combine. We countered this by limiting Combine to where it provided clear value. We adopted it incrementally, starting with specific modules. We also ran internal workshops to bring everyone up to speed. The result was a smoother transition and stronger team alignment. Looking ahead, the future consists of reactive AI and UX combined with each other. We'll see a lot of fusion with AI-driven personalization, predictive UIs, and seamless user flows. The Combine and Swift UI will dominate and evolve declarative paradigms. The winners will be teams that can orchestrate streams of user and system data into experiences that feel human. Imagine an app that updates your dashboard before you even open it, predicting what you want next. That would be so amazing. And you will be able to create or make changes seamlessly and efficiently. A few tools that we leaned on was Combine Cocoa, which bridges Combine with UIKit. RX Swift still plays a role in legacy apps. Understanding both is a strength, and observability platforms like Sentry and Crashlytics gave us deep insight into runtime state and crashes. Those are very important to have a grasp on, how what goes wrong in real time. If there's one thing I hope you walk away with, it's this. Our reactive architecture isn't just a tech strategy, it's a user first philosophy. By designing with streams and change in mind, we are building for a future that's fast, reliable, and personal. Thank you all for your time and attention. It was a pleasure for me to share my two bits on reactive architecture in iOS. If you'd like to continue the conversation, please connect me with me on LinkedIn.
Okay, thank you very much. That was Rutol Desai and scaling iOS with reactive architecture. Great, deep technical talk as always. And Manfred is on a stage. Hello, Manfred, again, because
Hi.
I actually been waiting to talk with you, man. And yeah, unfortunately, both other speakers they said they won't be able to join us to the Q&A session, so we'll be talking only you and me today. But we have plenty questions to answer.
Awesome. Awesome.
Yes, and let's start from this one. How do you assess maintainability when AI-generated code lacks consistent naming conventions or structural patterns, complicating
Mhm.
static analysis?
Yeah. So this is nothing you can do with a forensic analysis. And I think it's an issue in general, consistent naming with and without AI, because, each and every developer has its own style, and somehow we want to reduce that so that the code is maintainable in the long run. So, in my opinion, what you need is a good set of linting rules that enforce specific things. Of course, not exactly the naming, that would be a bit difficult, or it's at least unusual. And besides linting, I would do this in the review process using peer reviews, where you need to discuss your pull request with other people so that you make sure it is aligning your guidelines you have. And usually I don't invent my own guidelines. I try to go with default guidelines like those from the TypeScript team, those from the Angular team, because at the end of the day, it does not matter that much how it looks like, but what matters is that it is uniform.
Yeah, thank you very much. And one thing I wanted to add here actually about rules. Let me share the screen because I saw this demo from this team while we preparing to CTO Global Summit, and it's something crazy actually because this is Encoder, and this is coding agent like Windsurf or Cursor, but for VS Code, and they mostly focus on non JavaScript languages. But what's important here is that they created this shareable agent. So when you code, you can create an agent with rules about naming or whatever, and share across the organization. So everyone who actually runs this agent can be sure that the initial policies or rules are actually implemented in this code, or this code comply to them. So this puts the problem of standardization of rules and everything on very different level, very automatic level. So probably we will have soon some kind of the set of kosher rules or accepted or official rules packed in agents that will make will follow the code base, and you know what I mean, right? So that was something unusual and very very modern. I decided to share about that. Sorry, and we're moving on to our next question. If you could read it.
Differentiating meaningful dependencies from coincidental ones caused by AI-generated boilerplate. Yeah, so usually you have an idea about your architecture. Usually you want to have your verticals, your business domain, stuff like this. And if you see that you have too many connections between them, you should at least think about what's going on there. And then you need to start a discussion with the team. You will together very likely look at the connections that cause this. And then you need to come to a decision. Perhaps you say, well, 5 connections is okay-ish here, or you say, no, we have to avoid this because 50 is far too much. And when avoiding this, of course, the easiest way would be to say, you are a bad developer, you are not allowed to do this. But quite often, this is not the right approach. Perhaps it's really showing you that you need to rethink your architecture. Perhaps you need to slice a bit differently into pieces that are more or less self-contained. And obviously, there is never ever the perfect slicing into verticals, the perfect slicing into business domains. It's always a question of trade-off. That's why doing a deliberate decision there is important. Saying, okay, we go with this slicing, we know we have those drawbacks, but we also know we have this and those benefits. And that's why this is the solution that has more benefits than drawbacks for us, and so we go for it.
Thank you very much for answer, and thank you, by the way, for mentioning CodeScene. I know these guys for years. Highly recommended tool, and I'm not sure if this is the silver bullet at the times of AI generated code or not, but I'm not sure if they are using AI. Do they?
Not that I know. When I checked it the last time, they did not use AI for this. There might be some areas where AI could help, but in general, it's about looking at patterns that are unveiled when you investigate your source code. So I would say, regardless whether your source code is written with AI or not, those analyses make sense.
Absolutely. Thank you. Thank you for sharing this again. I really love when you guys speaking, you include lots of tools you are using for this topic. I really love this approach. Thank you very much. And yeah, let's go to the next one. Probably this. Let me pull it up. Yeah, how do you deal with noisy data from repeat prototyping or legacy branches during forensic analysis?
Yeah, so one thing that's important when doing a forensic analysis is to limit the time frame, because you don't want to investigate issues you don't have even more, because the issues are really down in your change history and perhaps they are not relevant anymore. So limiting the time frame is one thing. And sometimes we have to exclude some files. Just one example. When I wrote Detective, I tested it with the code base of Angular, because I know Angular quite well, and for me it was interesting to see this framework from this perspective. And at first glance, it looked like that just one person did more than 90% of the work. And so I got suspicious and looked a bit more closely into it. And funnily, the time frame I analyzed was the time frame where they introduced Prettier for code formatting. They introduced it little by little, module by module. And that's why it's clear that this guy touched almost all the files, because he basically ran Twitter there. And this was then a commit I needed to exclude. So it's about both excluding some files, but also commits with some characteristics, and also limiting yourself to a good time frame. Now your voice is gone. I don't hear you
Yes,
anymore.
yes, yes,
Oh yeah,
yes. I
perfect.
was muted. Sorry again. And yeah, limiting yourself. I said that was nice part. Actually, what's your approach when hotspot results point to code that's stable, but business critical? Do you still refactor?
Well, yeah, good point. So one thing that is interesting is, and this is also something the forensic analysis cannot tell us, if the code was stable in the analyzed period, there will not be a high code churn. So if you say we implemented this once in 2070, and since then it was not touched, then you will have a very low code churn, even though there might be an issue in there. And I would say, when it comes to those aspects, we as technicians, we as architects, can only show that there might be an issue, that we have, let's say, a high complexity in there, or that everyone has bad dreams when they know they need to modify something in there. We can show this up. And at the end of the day, as it's also about money, it's a strategic decision. Perhaps the management is saying, okay, this is stable. We know it's not in a good condition. It's stable, but we have more important things to do in order to achieve our company goals, our strategic goals. Or they might say, well, now it's important to make sure that this here works and that this here is maintainable because we need to achieve this and that. Also, an example on this, there was this machine factory I did consulting for. It's already several years ago, and they had a software that really worked in their factory. It was really tailored for their factory. It worked well, and they achieved a lot of goals. They automated a lot of processes. However, internally, the code quality was not that great, but it did its stuff. However, then the requirements changed. Then the management decided that they want to sell this software to other factories. And that means we needed to adjust the software to different machines there. We needed something like a driver concept. And this was where suddenly this bad style, this bad shape of this part of software became an issue, because integrating further machines there, adjusting it with a driver concept to other factories was nearly not possible. And this was where we started with a larger refactoring. Also for this, we needed to convince the management. What I usually like to do is give the management several perspectives, because I always say what you find out when doing an analysis is a weak indicator. However, if several weak indicators are pointing to the same direction, they become somehow a stronger indicator. So what we did there was an interview with developers. What do you think? What are the issues in there? What prevents you from falling asleep tonight? We did some estimates on how expensive it would be in terms of man days, person days to adjust the software to different needs. We also did static code analysis. And so we had several indicators, not only the code analysis, but also other indicators pointing into the same direction. And so the management said, yes, this is a strategic goal. We see the indicators tell us, all of them tells us we need to do something there. So we know now we need to invest in a larger refactoring.
Great, thank you for this story. And yeah, probably story is the best thing we can learn from, actually. Again, thank you very much. These were all questions I had, and thank you for joining, for sharing this
I thank
expertise
you for having me.
and energy. Happy to have you again, and welcome back to CTO Summit and next Architecture Summit, of course. Thank you very much.
Thank you. See you around.
Yeah, bye. All right, dear audience, we're moving on. We're going to have a little break, not too small, actually. We'll come back all together in like 25 minutes already, almost 25 minutes. So we'll have time to take our lunch, coffee, or whatever who has, and come back to hear the next speaker. And yep, let's take some rest. All right. Our break is over, and I have Ranjit on my backstage. We have a small change in our agenda, but very slight one. Hello, Ranjit. How are you?
Hi Ed, I'm doing good. How are you?
Doing great. Thank you very much. Thank you for coming, and thank you for preparing this talk and being ready to share with the community your experience. Augmenting architectural design with AI, evaluating the role of generative AI in software design. Why did you choose actually this topic?
Yeah, it's a trending topic, right? Gen AI and the use of that in the software development. Um, so I'm an architect, and I've been doing some studies on how we can use Gen AI tools for software architecture, and this is a presentation on that. I mean, based on my research work.
Right, right, right. Thank you very much. The AI is a hot topic now, and
Yeah.
lots of questions. Is there some positive ROI or outcomes? Does it make sense to apply it here and there? And yeah, I hope your um, session will help us understand more about that. Okay, the stage is yours. Let's probably first connect your slides.
Oh yeah.
You need to share the screen. Yeah, I see something. Yeah, we can see it. All right. All right. You did good. The stage is yours. Good luck.
Okay. Thank you. Hi, my name is Ranjit Ramachandran. I work as a senior solutions architect for BJ's Wholesale Club. Um, Today, I'll be covering the topic transforming software architecture design with intelligent assistance. It's a comparative analysis how AI tools are revolutionizing software architecture design processes and enhancing architect productivity. So the impact of Gen AI has been tremendous in the past couple of years, um, right from software development to delivery. It has been used to streamline the process, increase the productivity. Um, so in this session, I'll be covering the use of Gen AI products. I mean, Gen AI products like ChatGPT, GitHub Copilot, or Blackbox AI for the purpose of mm, creating software architecture diagrams. So yeah, going to the agenda. So I'll give an introduction, then software design of fundamentals. I'm not going to give a brief on software design, just the basics. Then introduction to AI assistant tools like ChatGPT, GitHub Copilot, Blackbox AI. I have chosen three, but there are more. Literature reference. So as part of this talk, I'm using e-commerce design as the reference, which was created many years back and being used in the academic world for teaching UML diagrams, like a software design artifacts. So like it was human generated. So as part of this talk, like I'll be using that as the reference, and take extracts from that, the basically the functionality of it, and use that for generating artifacts for using AI assistant tools like ChatGPT, GitHub Copilot, or Blackbox AI. So I'll be showing like how it works, like how sample prompt looks, how the outputs would look. I'll be comparing the results, like how it looks, then future scope, conclusion, and the questions. So moving on to the study, like as I said, enterprises are adopting AI assistant tools like GitHub Copilot for speeding up the productivity of the software development and releases. So that makes the life of software developers more easy. They can have code, documentation, um, crazy XMLs generated with just a few prompts. And there is still like the concern about the data sharing, and that has also been solved by many of these tools where data is not referred or shared with outside world, and also not used for the training of these models. So with the greater adoption of these tools, there is limited research or study on how these tools can be used for the for software architecture. So software architects gets involved early in the stages of the application. They go through multiple iterations. They create design. They work on the environment setup. They work on the release planning. So it's a long journey, and a tool like a GitHub Copilot or ChatGPT can help them to increase the productivity, help them with different artifacts, and speed up the word process. So and even like you can use that for creating your mockups or mock applications, which you can put in different environment and test it. So so that's the focus of this discussion, where we'll discuss on the use of Gen AI tools for creating software architecture artifacts. So a quick overview of software design. So here I have chosen a use case diagram, class diagram, sequence diagram, and state diagram for presentation. There are other diagrams that we use, but this will give a basic idea how software architecture works, and also like how these tools can be used for generating these diagrams. So here I'm showing a use case diagram. So use case diagram, it has a user and a customer. So here it simply shows a login flow where user logs in. There are different transactions that they can do. They can list a transaction. It's a banking application where you can open an account, you can open a deposit a check, or transfer funds. So that's a use case diagram, basically the functionality and the user's interaction with the system. So class diagram is primarily used in the design of object-oriented systems. It basically illustrates the attributes, methods, the relationship between the objects. So that's basically from a class diagram, mainly used for object-oriented languages like Java or .NET, or other object-oriented designs that are being used in the industry. So sequence diagram is basically how a system interacts with the different components of or a user, or a system, how it interacts with the different components of the application. So here, as shown, like the diagram is pretty, like a little small, but here user is interacting with a client and an authentication service and a database. So basically, this is one of the key diagrams that architects create during the software design process. And it basically shows all the interactions end to end. And a state diagram is used to describe different states an application component goes through. And basically, like in the same banking application, so if an account is created, then it goes to an inactive state if it is not used for a certain time. And then email verification, where you do you verify the user, you make them active, and if their account goes through some fraud, you get suspended and then get reinstated. So that's the different states a system goes through. So this is an overview of AI assistant tools. Basically, GitHub Copilot is pretty common and famous. among the developer community. So it's an AI-powered coding assistant. It was launched in 2021. It integrates with most of the IDEs. So you'll pretty much get a plugin. You have to install the plugin, and then you have a chat interface, or you can have in-code assistance where you can just click certain shortcuts and get the complete code written. So pretty much useful for documentation, creating test cases, creating boilerplate code, and also for tasks that you usually do repeatedly, and also for generating code also to some extent. But we'll have to make sure that the it's not just a copy paste of the code. Like whoever is using it pretty much understands how that works. ChatGPT, mm, again, famous, may not be from a coding assistant perspective, but it has all the features to help with the coding assistance, and it is used for generative pre-trained. It's a generative pre-trained transformer that produces human-like responses. It's trained on diverse text sources. Again, black box AI compared to GitHub Copilot and ChatGPT. Black box AI is pretty much used for the development of the for the software development. Basically, it has it can auto generate the tool based on the natural language inputs, and it aims to boost the productivity. So, like I mentioned, like these are some of the key features of GitHub Copilot. It was launched in 2021, powered by OpenAI models. So you can switch the models and get more accurate results. It offers autocomplete features. It basically asks for questions and you can populate the code, and it can generate documentation. I will skip. I mean, like I will just go through it. ChatGPT is again like it's a chatbot developed again using OpenAI. Was launched in 2023, and from coding assistance perspective, it can write code, it can debug code snippets in different languages. It has integration with the IDE, and it's again useful for content generation also. Like that's pretty much what it's used. Black box AI again is a AI powered tool. It's specifically used for coding assistance. It helps developers to overcome coding challenges. It can help to generate code. It can give real time suggestions, and it has extensions or plugins which you can use in your IDEs. So it can analyze code. It can have references to library. So black box AI is basically more coding assistant, more designed towards coding assistant, similar to GitHub Copilot compared to ChatGPT. So as I mentioned, like I'm referring software requirement specification, a book which was published in 2007. It was published by Michigan State University, and it has a software requirement specification for an e-commerce system which sells books. So it has software requirement specification. It has UML diagrams like class diagram, sequence diagram, and different types of diagrams which we can use for our analysis. And those were human generated, like the author created. I mean, the authors created those diagrams, and as part of this discussion, we'll be comparing human generated with chat gpt or like AI generated diagrams. So getting into the process, basically, so on the left you see the prompt structure. So as part of this experiment, I took the PDF version of the book, created like a summary of all the features that are developed, like available in that SRS, like a software requirement specification. And based on that, I came up with a sample prompt, which I gave it to all these three AI assistant tools like ChatGPT, GitHub Copilot, and Blackbox AI. So here on the left, you can see like I'm asking the AI tool to consider that you are a solutions architect and you create a use case diagram in planned UML format. So planned UML format is a way that you can use to codify your diagrams. So in the middle, you will see that the planned UML diagram, like a planned UML code that was or a markup that was generated, and that markup is given as input to your visualization tools like a Lucid Chart or Draw.io. So I basically use Draw.io because it is freeware, and use that for generating the diagram. So basically, the flow is like you create a prompt. You like towards the end, you can see that create a planned UML diagram, and I'm giving all the functionalities that are part of the software requirement specification. I'm giving that to ChatGPT, GitHub Copilot, and Blackbox AI. Based on the input, they generate a planned UML diagram. So I have included a sample from GitHub Copilot, and then you give copy that planned UML diagram and give it to a tool called Draw.io, and then you generate the diagram. So um, that will, like, instead of spending hours to create a diagram, you can have your diagrams created in short span of time. And also, like, you can get, like, as we go through the slides, should be able to see that we get more accuracy compared to human generated ones. So moving on to the diagrams um, that were generated. So it's like I was trying to fit all the diagrams in one slide so that I can do a comparison. So it's a little hard to see the wordings in the diagram, but yeah, I will explain it in the best way I can. So towards the left, you can see the diagram from the reference literature. That's the book. So it has captured the user. So as part of the software requirement specification, there are two users. One is the actual user who is buying the book. He can add books to the cart, check out, and make an order placement. And there is a manager who can add books to the inventory, update the inventory, apply promotions, and all that stuff. Same with the user can also apply promotion when they are checking out the books. And also, like, manager can change the price and all that stuff. So next to the reference literature diagram, you can see the diagram generated by Blackbox AI. So Blackbox AI could capture most of the functionalities that were referenced in the um, book, and also, like, you can see that it could capture more than what a human generated diagram could capture. So that way, like, here you can see that there are two roles, like the manager and the customer, and both the functionalities have been captured pretty good compared to the reference literature. Next, you can see the use case diagram generated by GitHub Copilot. Again, you can see two user groups, like the customer and the manager. And same as Blackbox AI, GitHub Copilot also could capture all the functionalities um, which were referenced in the software requirement specification. And again, it is pretty comprehensive. It is capturing a lot of functionalities compared to what was captured by the reference diagram. And same with towards the right, and you see the use case diagram generated by GitHub Copilot. So GitHub Copilot also could capture a good amount of information, and the AI model, like, if you look at it from a visual look, you can see that it is not as good as ChatGPT or Blackbox AI. Especially, like, this one, the middle one is ChatGPT. I think I have a correction there. It's not as extensive as other two, mainly because the GitHub Copilot model that I was using is on an older version of OpenAI model. Blackbox and ChatGPT were using the latest model. So here you can see like as we compare the diagrams, you can see like these AI assistant tools are able to create more comprehensive diagrams compared to human generated ones. So now proceeding to class diagram. So here on towards the left, you can see the class diagram that was used in the reference literature. And towards the middle, you see the diagrams which are generated by ChatGPT, GitHub Copilot, and Blackbox AI. So again, here you can see that GitHub Copilot did not come up to the mark of the reference literature. Like as I said, GitHub Copilot was running on an older model. But if you see at ChatGPT and Blackbox AI was using the latest model, and it could capture more details compared to the reference literature. So it could add comma, it could find more relationship between the entities. It could find more attributes in the class level, and it could capture more functionalities. So it's very evident that these tools are good in capturing more information compared to the human generated ones, and at the same time they are of great help to the software architects, like especially when generating these diagrams. So to conclude, as we saw in the diagrams, like the adoption of AI in the software architecture design workflows will boost the productivity. They can capture more information. Only thing is like you'll have to keep an eye on to make sure that they are not capturing that is not something not required or like out of scope. It definitely increases the productivity. It helps in time, like it saves the time a lot, and it can be a comprehensive diagram compared to manual creation. So they can like to conclude like AI assistant tools can generate more information that a human created references, as demonstrated in the results. So yeah, that's all I have. Any questions? I think there is a separate session for Q&A. So thank you.
Yeah. Thank you very much for bringing this up. Actually, thank you for this presentation. And will you be able? I missed this part. Will you be able to connect to the panel Q&A session in 1 hour, or it's or you can't?
Yeah, I will be able to connect. So is that the same link or is it a different link?
The same link, the exact the same link. Okay, and let me show real quick because what you showed is great, but here at Geekle AI Labs, just I wanted to hear your feedback. At Geekle AI Labs, we're working on Zero Docs, which eventually does something like you showed, but it's more kind of productized and with connected to the code base and with let me see, with continuous updates for the content, and generates not just diagrams but also the content, descriptions and everything. So yeah, and we're planning in closed beta this weekend. So if you're interested, I would love to share it with you.
I didn't get that. Like this weekend, like what are you?
Yeah,
doing?
we're this weekend we're going to start the early preview of this tool.
Okay. Yeah, that's good. Yeah.
Like like beta versions, and beta testers, and I will share it with you. Okay, thank you very much for this approach, and that's really something into that, and at least it creates a great templates, right? From which you can elaborate and go on in your documentation. Thank you very much, and see you in few, right?
Yeah, for one question I had, like for the Q&A session, should I be on cam or can I answer from phone?
Well, normally is on cam, but
Okay.
if it's not something comfortable for you, just skip it. Okay.
Okay. Yeah. Let me see. Like I need to go
Okay.
to office, so let me see. Like if I
Yeah.
possible, I
Okay.
will join
Just let
first.
us know. Okay.
Okay.
All right, ladies and gentlemen,
And
we're moving on. Yeah.
okay. Okay then.
Yeah. We have to move on with our agenda, and our next speaker. Just a second. Yes, our next speaker is Nilanjan Chatri, data governance in a medallion world. Let's see what's that.
Chatterjee, Senior Staff Data Architect. I'm Nilanjan Chatterjee, Senior Staff Data Architect, and today I'm here to talk about data governance in the Medallion world. Okay, let's get started. So let's start by taking 10,000 feet view of the Medallion architecture and the evolution of the Medallion architecture, how it came into being. The coin was termed by Databricks, which basically governs or the process of outlining what all different components are present in a data processing pipeline. We start off by creating a landing zone for the data from different sources, batch streaming real time. The data lands into the bronze layer, which is the landing zone, and no further transformation is needed. So without transformation, there is no use for a schema. Bronze layer serves as just the landing zone for all raw data. Silver level, the next layer, is where the structure is created, schema is enforced, and schema can evolve as needed. In the gold level, which provides the business level aggregates, we deliver continually updated, clean data to downstream users and apps, which is used by BI and ML use cases. We also need to talk about data governance best practices. So what is data governance? Data governance is a framework which is a structure of rules, policies, standard processes, which make up the data governance for an organization. All these pieces work together when teams and employees implement these and work in tandem. Data stays secure, accurate, compliant, and accessible. There are four major components of data governance framework. First, data policy, which defines how well-defined rules clarify the requirements for data usage in the organization, including how the data is stored, used, accessed, and shared across different teams in the organization. Data stewardship. Data stewardship concerns the roles and responsibility of data and also involves standards for data access, ensuring the appropriate teams can leverage the data to drive business value. It defines clear roles of who can access what portion of the data and for what use case. Metadata management is critical as well. Metadata is the data about data, so including its context, structure, origin. Metadata management involves its organization and storage, which needs to follow similar security, integrity, compliance, and quality standard as the data itself. There are security measures which needs to be followed. Security measures are all the safeguards a company puts in place within its data governance strategy to keep the data from being destroyed, disseminated, or accessed by unauthorized users. These policies prevent data leaks and involve access control, authorization, encryption, both at rest and in transit, and monitoring policies. How do we achieve that? as recommended by major industry leaders. That is achieved by defining clear roles and responsibilities, assigning data owners, stewards, and a chief data officer if need be to oversee governance and democratization. We need to constantly uplevel and train teams to focus on business benefits of governance and provide ongoing training on policies and procedures. We also need to set data quality standards, use frameworks like FAIR to ensure the data is findable, accessible, interoperable, and reusable. We also can balance agility and structure of the data by integrating secure access with flexible policies to encourage collaboration depending on which level we are working with, be it bronze, silver, or gold. We can have the right level of access control in place. We should also leverage automation, automate all the manual process to reduce the risk of any kind of data leak or any misclassification, to streamline governance and improve efficiency. These days, a lot of these steps are done with the help of AI, maybe agentic workflows. So it would be a good area to look forward to. Coming to the Medallion architecture. What is exactly Medallion architecture? A Medallion architecture is a data design pattern which, when used correctly, organizations can benefit a lot. It is used to organize data logically. The goal is to incrementally and progressively improve the data and the structure and the quality as it flows through each layer. In this particular example, as it flows from bottom to top, from bronze to silver to gold. We are also seeing another layer on top of gold, which is platinum, which we'll discuss towards the end of our talk today. Medallion architecture is sometimes also referred to as multi-hop architecture. It's a sophisticated approach in data management and organizes information processing into distinct quality tiers, with progressively higher level of refinement and trust for each tier than the previous one. We start off with the bronze layer, where the raw unprocessed data lands, gets moved into the silver tier, where the data is cleaned, validated. A lot of validation steps are performed in the silver layer. And then we come to the gold layer, which creates business-ready curated datasets. And finally, in the platinum layer, as being discussed of late at different organizations, it provides advanced specialized data product for specific business use cases. This architectural pattern is becoming the foundation for modern data platforms like Databricks and Snowflake, providing a structured approach to data quality progression. Each layer serves as a specific purpose in the data refinement journey with appropriate governance controls at each stage. Moving on from the Medallion architecture, let's take a closer look. Let's dive deep into each step. The bronze layer, that's the first layer. The bronze layer acts as the initial landing zone for all data entering the system. Here the information arrives in its original format, unprocessed form, from a variety of different sources, including operational databases, IoT, clickstream, third-party feed, and it provides full fidelity storage maintenance as needed as the data is received and stored in the same format without any further processing, without any transformation. And since the original state is maintained, it can provide regulatory compliance and also support future reprocessing needs. The data is immutable because no transformation is done, so it provides historical traceability and can enable point-in-time reconstruction of the dataset, supporting any audit request or historical analysis if needed. So at the bronze level, data is appended incrementally and it grows over time. It is intended for consumption by workloads that enrich the data for silver tables and not for access by any analyst or any engineer. This bronze level serves as the single source of truth, preserving the data's fidelity. It enables reprocessing and auditing by retaining all historical data. And it also supports rapid ingestion because minimal processing is done, enabling high throughput data capture, supporting both batch and streaming scenarios without transformation bottleneck. Data from different streaming and batch transaction from sources, like including cloud storage, for example, S3, GCS, ADLS on AWS, Google Cloud, and Azure respectively, message buses like Kafka, Kinesis, and federated systems like Lakehouse Federation, all that can be supported on the bronze layer. Minimal data validation is performed on the bronze layer. So to ensure against drop data, Azure Databricks recommends storing data in the newest field which has come out called variant or binary format to protect against any unexpected schema changes. Metadata columns might be added, such as provenance or source of the data, for example, metadata file name, but that's about it. What kind of governance can we expect at the bronze level? Bronze level governance focuses on establishing proper controls for incoming data while maintaining flexibility for diversity of different formats and sources. So for foundation of governance, bronze layer is the initial landing zone for all incoming raw data, capturing in its original unprocessed state from diverse sources and formats. It can provide minimal processing and high flexibility. So data is ingested with minimum validation or transformation and is maintained so, preserving fidelity and enabling schema on read for maximum flexibility. Bronze layer also enables control and traceability. So proper controls are established for schema or data ingestion, including metadata for lineage, auditability, historical archiving, setting the groundwork for downstream governance and quality checks. It supports scalability. This approach ensures efficient handling of large data volumes and enables future reprocessing or enrichment as needed. This governance measures at the bronze level ensure raw data remains secure and traceable without imposing any excessive restriction that would impede the ingestion process. We come to the silver layer next. In the silver layer, raw data goes through significant transformation. This critical phase applies business rules, standardization process, validation checks to create reliable, consistent datasets that serves the foundation for enterprise analytics. So we start off by refinement of raw data, where the silver layer takes raw data from the bronze level, applies cleaning, transformation, validation steps to improve quality and usability. In the data cleaning process, the data goes through deduplication, error correction, handling of missing values, filtering. Through the validation step, it can also go through schema enforcement because that's where we create the tables and the views. So ensuring the data conforms to expected formats and types is needed, like date should be valid, number should be within expected range. Business value validation checks that the data needs to meet for specific business logic, like valid customer ID, valid transaction amount, things like that. Referential integrity should also be maintained, verifying that the relationship between datasets, like the foreign keys, are intact and valid. We also enable or implement data transformation at this level, where normalization and standardization, converting data into consistent units, formats, and naming convention, which should be same across all the sources. Data enrichment is done here, where we add context or derived fields like geocoding address, maybe calculating age from date of birth, things like that. Integration, like merging data from different sources, resolving discrepancies and aligning structures, is also part of the silver layer. We also enable auditability and traceability by logging all changes, logging all metadata updates, tracking all cleaning and validation actions for transparency and reproducibility, recording data lineage, noting transformations and data quality issues. The output of the silver layer is a clean, validated, standardized dataset that is trustworthy, consistent, and ready for advanced analytics, reporting, or further processing in the gold layer. Silver layer governance focuses on implementing consistent quality standard and ensuring appropriate transformation rules that are applied. This middle tier requires more sophisticated control as data becomes more structured and widely accessible. How do we implement that? This is done using quality monitoring, schema enforcement, privacy controls as the three major pillars. So for data quality control, the silver layer applies governance by enforcing data quality such as cleaning, validation, deduplication, and basic transformation. All we need to do. This ensures that data moving forward is accurate, consistent, and reliable for enterprise use. Data from various sources are matched, merged, and confirmed to standardized format and business rule, providing an unified enterprise view of key business entities and transactions. Governance practices include metadata, maintenance, tracking data lineage, and documenting all the transformations. This supports auditability, traceability, and compliance requirements. The silver layer structures data to facilitate different self-serve analytics, making clean and validated datasets available to different analysts, engineers, both technical and non-technical users, while maintaining access control and governance policies valid. Automated validation process and continuous monitoring is implemented to promptly identify and address anomalies, further reinforcing governance and data quality. And throughout this process, we enrich the data and make it ready for advanced analytics by ensuring the data is trustworthy and well governed at this stage, which lays a strong foundation for downstream analytics, reporting, and machine learning, which will take it up in the gold layer. So this layer, the silver layer, strikes a balance between ensuring data quality, enabling broader access, creating a foundation that supports downstream analytical process while maintaining proper safeguards. We come to the gold layer next, where gold layer is the pinnacle of the data refinement process, delivering purpose-built dataset optimized for specific business use case. This is where data achieves the highest value state, ready for immediate consumption by business users and analytical applications. So gold layer emphasizes, or gold layer basically enables all the data owners and supports trust or builds trust because it acts as a single source of truth for all the business metrics and KPIs, which are tracked on different dashboards and reports. We do it by analytical optimization, where gold datasets are structured for performance with denormalized schemas, pre-calculated aggregations, and query-optimized formats that dramatically improve analytical response time. This optimization makes the gold data ideal for interactive dashboard and real-time reporting, where speed is essential. Unlike lower tiers that focus mainly on technical organization of the data, gold datasets are designed around business concepts, using terminology and structure that directly align with how the organization thinks about the operations. So, data is denormalized for and structured for fast, efficient queries, reducing the need for complex joins and improving the overall user experience. And since gold layer already provides data which is highly refined, aggregated, enriched, this is optimized for reporting, analytics, and machine learning that serves as a single source of truth for all the business users and anything downstream of it. It provides a simplified consumption approach where aggregated and business aligned tables, often in star schema, make it easier for analysts and business users to access and interpret data without deep technical knowledge. Gold layer also supports proper governance and compliance, ensures that data quality, traceability, and compliance with governance policies is by enforcing final business logic and validation checks. Although we are discussing all the benefits of having a medallion architecture with bronze, silver, and gold, we can discuss a couple of cons or issues what may arise by having this gold layer. Gold layer particularly may cause information loss in certain scenarios because aggregation and denormalization can lead to loss of detail and flexibility, making it difficult to access raw or granular data for ad hoc analysis or new requirements. Gold tables or gold layer data assets are created at a fixed grain and it is inflexible. So gold layer tables have predetermined dimensions and measures, requiring engineering changes for new analytical needs, which can be very slow in response. So we need to create a new goal table for any schema change or a new metric you would like to track. It has to be a separate goal table by itself, which will be an engineering effort. It's not straightforward, which will be handled by a non-technical user or somebody who is just a consumer or viewer of that particular data asset. There is maintenance overhead for the goal tables because frequent updates are needed to accommodate evolving business logic, new metrics, schema changes, which increases the operational complexity and the resourcing demand to maintain this piece of the overall pipeline. While we implement the goal tables, we implement or maintain multiple layers, especially in the goal layer, which can incur additional compute, storage, and management cost, which can escalate at scale if there are multiple goal tables which needs to be created for different business use case. There is also a risk of data inconsistency. If not managed carefully, different teams may interpret or query goal layer tables very differently, leading to inconsistent metrics and decision making. So the single source of truth, the point we are trying to make, has to be very clearly defined, and it has to be clearly communicated with all the users on what version of the goal table they should build the reports on or they should be trusting. Since data also traverses multiple layers, which can introduce multiple delays, goal layer tables are generally not suited for real-time or near real-time analytics. That's challenging here. So to summarize, goal layer tables generally delivers business-ready, high-performance data for analytics and reporting. It introduces trade-offs like flexibility, maintenance effort, and potential information loss that organizations need to carefully manage. To start, the different governance process which we need to implement at goal layer involves business logic enforcement. Like the goal layer applies final business rules and aggregations, ensuring the data is fully aligned with organizational definitions and reporting standard. This guarantees consistency and reliability for analytics and decision making. We also have data quality assurance implemented here. Continuous data quality improvement is central to this stage, with regular audits, validation checks, and the use of automation tools to maintain data integrity, accuracy, and completeness. Data stewards play a key role in monitoring and sustaining quality over time. Robust governance frameworks at the goal layer enforce strict access controls, data protection policies, and compliance with regulation policies like GDPR, HIPAA, CCPA, GLBA. This is critical as the goal layer data is often used for external reporting and sensitive business process. The goal layer also maintains detailed metadata and lineage, documenting all transformations and aggregations. This supports audit requirements, which enables organizations to trace data back to its source and run the whole pipeline. If the data needs to be regenerated, some raw files needs to be reprocessed, they can identify which exact file at the bronze level creates which set of rows at the silver level, which in turn populates the gold level tables. And gold level tables can also enable self-serve and accountability. Well-governed gold layer data empowers business users to access trusted, business-ready datasets for self-serve analytics, while clear roles like data stewards, chief data officers ensure accountability and oversight. Governance at this stage is not static. Organizations need to constantly dynamically improve and align with newer standards as and when they come up, and leverage technologies like AI, agentic workflows to improve the continuous monitoring and any kind of anomaly detection, data drift detection in their pipelines. This brings us to the next piece, which we didn't discuss initially. That's the platinum layer. So while gold layer provides business-ready aggregated data for analytics, organizations are discussing another layer on top of gold, which is platinum, to address some specific limitations of gold. Like platinum layer is an extension of the traditional medallion architecture, addressing specialized use cases that require some extraordinary level of trust, customization, and performance guarantees. Gold layer datasets can still be large and complex, requiring technical expertise to query. Platinum simplifies this with pre-processed insight, SQL-friendly structure, or visualization-ready format, like it can directly integrate with Power BI. Platinum tables have a faster time to insight. So Platinum layers apply advanced aggregation, predictive modeling, or curated dashboard requirement. All this can be supported at Platinum level, allowing users to bypass complex queries on Gold data. For example, there are different offerings from Databricks and Snowflake, which do support Platinum table requirement. Platinum is also optimized for performance, like maybe using serverless warehouse like Databricks Photon, or columnar storage to accelerate query speeds for specific business use cases. While Gold tables focus on enterprise-wide metrics, Platinum tailors data for specific niche use cases like forecasting, customer churn, or drug commercialization. As we were discussing, Platinum layer and how organizations implementing Platinum layers often establish dedicated cross-functional teams responsible for both technical capabilities and enhanced governance requirements these specialized products demand. So let's take a few minutes to discuss some of the challenges of the Platinum layer as well. Because similar to Gold layer, Platinum layer has some trade-offs which we need to account for. There may be data duplication, because at the Gold level, we are curating some of the data feeds, and at the Platinum layer, we are representing them with some added data sources merged together with the other Gold tables. So that increases the storage cost and complicates governance. There may be fragmented access, like risk of silos if Platinum exists outside the unified platform, for example, OneLake. There can be additional latency requirements, causing transformational delay in data availability, and obviously it adds maintenance overhead for pipelines and access controls. The Platinum layers addresses Gold limitation in scalability, usability, and specialization, but risks undermining the Medallion architecture's core principle and unity and simplicity. Organizations should weigh in these trade-offs carefully before adopting Platinum, only if business needs to justify the added complexity. For most of the use cases, optimizing the Gold layer with materialized views, caching may be preferable than introducing a new tier. We come to the last piece of the overall talk, which is comparing all the Medallion layers. We have Bronze, Silver, Gold, and Platinum. Bronze is most restrictive, and it provides basic access control. Silver provides role-based access control. Gold has purpose-based access control, and Platinum is zero trust. Bronze provides quality standards, same as the raw files as they come in. At Silver level, we do some technical validation and provide or enforce schema, because the schema is defined at the Silver level. Bronze level is generally owned by the data engineering team, and it has the same source metadata because we don't do any transformation there. Silver defines the schema, and there is a wider data management team who controls the Silver tables. At Gold level, the ownership lies with the business units, and with the schema, the business context also gets added to it, so the business glossary is implemented. At Platinum level, along with providing zero trust access control, it provides continuous verification of the data which we get from Gold. It's owned by executive sponsors, and this is mainly externally focused, so it provides regulatory mapping. A lot of internal information may be redacted or will be aggregated with very specific information which is okay to share with external users. So as the data progresses through the Medallion architecture, governance maturity increases with each tier. The progression reflects the changing nature of data from a technical resource to a strategic business asset, with corresponding shifts in responsibility and oversight. Looking ahead, organizations are increasingly automating governance through policy engines that enforce consistent control across all the layers. This automation, combined with enhanced lineage tracking, will enable more agile responses to regulatory changes while maintaining the integrity of the entire data lifecycle. By implementing appropriate governance at each stage of the Medallion architecture, organizations can balance innovation with control, ensuring their data remains both useful, trustworthy, and they can clearly identify the single source of truth. That's all about the talk today. I'll conclude here. I'll open up the floor for any questions. Thank you.
Thank you, Nilanjan. Thank you very much. And that was actually nice. And we're moving to our next speaker, which is data scientist driving ROI through driving ROI through automation, AI, QA, UX design, and agile DevOps across industries.
Hi everyone, my name is Datta Snehit Dupakuntla. Today we will be looking into this topic of driving ROI with AI and automation. As we explore this topic, it's essential to recognize how these technologies are reshaping our organizational landscape. The focus here is not just on the technology, but rather on the profound impact on the return on the investments. The main theme of this presentation revolves around the transformative effects that AI quality assurance, user experience, and the agile DevOps practices have on the return on investments. By leveraging these advanced methodologies, businesses can streamline their operations, enhance their efficiency, and ultimately drive greater profitability. Let's break this down further. First, consider the AI quality assurance. This isn't just about the testing software, it's about ensuring that products meet the highest standards before they reach the market. By automating quality checks, organizations can significantly reduce the time and resources spent on the manual testing, leading to faster product releases and improved customer satisfactions. This is not only enhances the brand's reputation but also contributes positively to the bottom line. Next, we have the UX design. A well designed user experience can make a monumental difference in customer retention and their satisfactions. When a user finds a product intuitive and enjoyable to use, they are more likely to engage with it on regular basis. This engagement translates to loyalty and ultimately increased revenue. Investing in the UX designs can yield higher returns by fostering deeper connections with the customers. Lastly, the agile DevOps. This would be the third one. The approach brings the together development and the operations in a collaborative framework that promotes their continuous improvements. This methodology allows the teams to adapt quickly to the changing market demands, ensuring that business can pivot when necessary. The efficiencies gained through agile DevOps practices results in the reduced operational cost and faster time to market for the new features or any products which has been developed. This will ultimately again further enhances the return on the investments. Now we transition to the next topic. We will explore how automation is fundamentally transforming various industries. The transformation is not just limited to the tech companies. It spans across healthcare, finance, retail, manufacturing, and thus showcasing the widespread benefits that these practices can bring. Let's dive into how these sectors are harnessing automation to drive efficiency and their cost effectiveness. Okay, now let's look at the automation impacts on the industries. As we dive into the transformative effects of automation across various sectors, it's essential to recognize how the technological shift is not just a trend, but a fundamental change in how industries are operating nowadays. Key points we'll be discussing here are automation is transforming the industries, key sectors benefiting from the automation, integration of the AI and the DevOps, cost reduction and the efficiency. Let's discuss one by one. Automation is transforming the industries. Automation is revolutionizing industries by streamlining their process and enhancing the efficiency. This transformation allows organizations to allocate resources more effectively and focus on the strategic initiatives. For instance, in manufacturing, automated assembly lines have significantly increased output while minimizing the human errors. The second one is key sectors benefiting from the automation. This includes various industries and sectors such as healthcare, finance, retail, manufacturing, etc. Each of these industries demonstrates widespread adoption of automation technologies. In healthcare, automation systems manage patients' records and streamline the diagnostics, while in finance, algorithmic trading and automated customer services are reshaping the whole landscape itself. Retailers utilize automation in a completely different way for inventory management and personalized marketing, showcasing the versatility of these technologies. Integration of the AI in the DevOps would be the next topic, where a pivotal component of achieving operational excellence is the integration of the AI, UX design, and the agile DevOps practices. This combination not only enhances the productivity but also fosters innovation. By leveraging the AI, organizations can utilize the user experiences more efficiently and iterate on their services rapidly, ensuring they remain competitive. The third one is the cost reduction and the efficiency. Organizations are increasingly adopting these technologies to significantly reduce their costs and improve the service deliveries. For example, by automating routine tasks, companies can reallocate their manpower to more valuable driven activities, ultimately leading to improved customer satisfaction and their loyalty as well. As we transform into the discussing how AI significantly enhances the quality assurance, we will explore the role of automation testing and predictive analysis in ensuring that products meet high standards. So the next slide would be AI enhancing the quality assurances. Yes, let's explore them. As we analyze the role of AI in quality assurance, it's important to recognize how technology is transforming traditional processes. The integration of the AI is not just a trend, it's a game changer in ensuring that reliability and performance of our products. The first point would be the automated testing with the AI. By leveraging the AI, organizations can conduct the automated testing that drastically cut down their time and effort typically required for manual testing. This means teams can focus more on their strategic tasks rather than repetitive testing process, leading to increased productivity and faster release cycles. Next, we have predictive analysis for the defects. The powerful tools allows us to identify potential defects before they reach to the end user. Imagine being able to catch errors during the development phase rather than after development. This proactive approach not only enhances the quality but also improves the user satisfaction by minimizing their disruptions. And this will significantly reduce the cost needed to fix a bug rather than fixing it after the development cycle has been completed, which need to go through the whole process of a planning, implementation, deployment, testing cycles. Okay, moving on, let's consider the continuous testing with the CI/CD pipelines. The integration of continuous testing ensures that feedback is rapid and ongoing, which is crucial in today's fast-paced development environments. Okay, that consistent cycle of testing and feedback enables teams to make iterative improvements, enhancing the overall quality of the software without slowing down their deliveries. Lastly, we can't overlook the improved accuracy on the return on investments that comes with AI-driven quality assurances. Organizations that adopt these technologies see significant improvement in their accuracy and efficiency, which in turn reduces their operational costs. A higher return on investment means like more resources can be allocated to the innovation part and also further enhancing the product. As we pivot to our next topic, we will delve into the importance of user experience designs. Effective UX designs is essential not just for satisfaction but also fostering the loyalty and driving the revenue. Let's explore how creating a user centric environment can significantly improve user retention and business success. Enhancing the engagement through the UX. Let's dive into this critical role of the user experience or UX in driving the engagement. When we think about how users interact with the products and services, we can't underestimate the importance of the effective UX designs. It's not just about the aesthetics, it's about creating a meaningful experience that keeps users coming back. A user experience design is essential for their satisfaction. When users feel that their needs are met and their interactions are seamless, their overall satisfaction rises significantly. This satisfaction is directly linked to retention and loyalty. Imagine a platform that is easy to navigate and pleasant to use. Users are much more likely to return to it time and again. Now let's explore the concept of user-centric design principles. By placing users at the heart of the design process, we can develop intuitive interfaces that make navigation feel effortless. This shift to a user-first approach not only enhances the usability but also ensures that users can move seamlessly across various platforms, leading to a more cohesive experiences. Next, we have the idea of continuous feedback loops. Establishing a system where users can provide ongoing feedback is invaluable. This practice allows designers to refine and adapt their strategies in real time, responding swiftly to user needs and preferences. It's also creating an agile environment where design evolves based on the actual user interactions rather than their own assumptions. Finally, it's considered that impact of the robust UI strategy on the business outcomes. A well-crafted strategy doesn't just lead to the happier users, it's also boosts their customer loyalty, which directly correlates to their increased revenue and the return on investments. Business that invest in the UX designs are often rewarded with a strong bottom line as satisfied customers tend to spend more and advocate to their brands. As we transition to our next topic, we will explore how agile practices are further enhance these user experiences by enabling faster delivery and more responsive design process. This approach not only aligns with user needs but also fosters a culture of collaboration and adaptability within their teams. Now, we look into agile practices for their faster delivery. It's important to recognize how these methodologies have revolutionized the project management and their delivery. The emphasis on agility has transformed the way teams operate, allowing for greater flexibility and responsiveness in every changing market. Starting with the iterative development, agile methodologies encourage teams to work in the cycles or iterations, which allows for regular reassessments and adoption of the new project. This means that new information arises or customer feedbacks is received as we are the development teams are working on it. We can still incorporate those changes without going through the whole process from the planning all the way to the development and the testing cycles. Now let's discuss on the enhanced collaborations. Agile fosters a culture of open communication among cross-functional teams, breaking down silos that traditionally exist between their departments. This collaboration not only leads to better outcomes but also builds a sense of shared ownership among the team members. When employees aligned and engaged, the creative solutions that emerge can significantly benefit the projects. The third key practice would be the faster release cycles. These are hallmark of the agile practices. By working in the shorter iterations, teams can release updates and new features more frequently. This quick turnaround is not just about the speed, it's about being responsive to the market demands and their customer needs. When organizations can adapt their offerings swiftly, they maintain a competitive edge. Lastly, the fourth practice would be improved project visibility is a significant advantage of the agile methodologies. Organizations that adopt agile report not only in the enhanced visibility into the status of their projects, but also greater stakeholder satisfaction. With regular updates and review, stakeholders are more informed and involved in their decision making process, which ultimately leads to the better project outcomes. As we transition into discussing the DevOps, we will see how this approach complements agile practices by further enhancing the collaboration across the team. DevOps bridges the gap between the development and the operations, creating a unified workflow that fosters productivity and efficiency. Let's dive deeper into how collaboration can transform our deployment processes. Enhancing the collaboration. As we delve into this topic of the enhancing collaboration within the DevOps, it's essential to recognize how pivotal this practice is in today's fast paced technology landscape. By bridging the gap between the development and the operations, DevOps creates a collaborative culture that not only boosts the productivity but also leads to more innovative solutions. The first point highlights that DevOps foster collaboration across the teams. This is more than just a buzzword. It is about breaking down the silos and encouraging the communication between the developers and the operational personnel. When these teams work together seamlessly, they can respond to changes more rapidly, leading to shorter development cycles and increased responsiveness to the customer needs. Next, let's talk about automated deployments. This practice is a game changer as it minimizes the downtime significantly. By automating the deployment process, organizations can ensure that their systems are not only reliable but also their services remain available to the users, thus enhancing overall user experiences. Imagine reducing the frustration caused by outages and downtime. This is a direct benefit of the adoption of the automation in your process. We also see how CI/CD process streamline these processes. Continuous integration and continuous delivery are instrumental in making the deployments more efficient and reducing the likelihood of these errors. With CI/CD, code changes are automatically tested, deployed, which means like teams can integrate and deliver their updates more quickly and confidently without worrying about the deployment process. This not only accelerates the release of a new feature but also helps in maintaining the quality as QA automation is also included in the CI/CD pipelines. Finally, the adoption of the DevOps practices leads to increase in the deployment frequencies. Organizations that have embraced the DevOps often report significant improvements in how often they can deploy new features or their updates. This increased frequency enhances the overall performance and ensures that companies are always in tune with the market demands and customer expectations. Let's assume a scenario where you are developing a feature which is like the key thing which has been needed by the customers. By the time you develop and test it and release into the production in the regular process, that customer needs may have been changed. So instead of that, if we use the agile, if we are in the middle of the development and if we feel that customer needs have been changed, we can definitely quickly go back to a different approach, or we can at least show the customers like we have been making a progress in achieving their needs. So that way adoption to the DevOps helps in delivering the products more quickly to the users. Now, as we are transition to the next topic, let's explore the tangible return on investments from adopting the automation process. We will discuss specific metrics that showcase the financial and operational benefits of implementing these strategies, illustrating how automation not only streamlines the process but also drives significant savings and efficiency improvements. Return on investments from the automation insights. It's clear that integrating these technologies can lead to significant financial and operational benefits for the businesses. Let's explore some of the key insights that underline this potential. First, we see an impressive figure of 500,000 in annual savings from automation. This highlights the substantial cost reductions that organizations can achieve by streamlining their processes. These savings often stem from decreased labor costs, reduced errors, and minimized operational delays. Next, the data indicates a 30% efficiency improvement. This is critical because enhanced efficiency not only speeds up the workflow but also allows teams to focus on more strategic initiative rather than the same repetitive tasks. For example, automating data entry can free up employees to engage in higher value activities such as customer relationship management or product innovations. Additionally, we have up to 20% enhancements in the quality. Automation minimizes the human errors, which is often a key contributor to the quality issues. By ensuring consistency in the process, business can deliver products and services that meet or exceed the customer expectations in some cases. This can lead to increased customer satisfaction and loyalty, which are vital for long-term process. Lastly, automation has contributed to 15% reduction in the challenges faced by the organization. This could relate to overcoming hurdles such as compliance issues, operational bottlenecks, or data inaccuracies. By addressing these challenges, companies can create a more agile and responsive business environment. As we move forward, it's essential to consider how to implement automation effectively to realize these benefits. The next discussion will provide the guidelines for successful automation implementation, ensuring that organizations can strategically align their automation initiative with the overarching business needs. Let's look at what are the main guidelines for achieving success using automation. It's essential to recognize that a strategic approach can significantly influence the outcomes. Automation isn't just about implementing new technologies, it's about aligning those technologies with our broader business objectives. The first key point emphasizes the importance of establishing the clear objectives before we take any step towards automation. What does this mean in the real-time practices? It means identifying the specific goals that automation will help us achieve, whether that's improving efficiency, reducing costs, or enhancing the customer satisfaction. But by aligning our automation initiatives with these objectives, we are not only set a clear direction but also provide a framework for measuring success. Next, consider how these objectives guide the choice of tools and processes we automate. For instance, if our goal is to enhance the customer service, we may prioritize automating customer support workflows or interacting chatbots. This targeted approach helps ensure that our efforts yield tangible benefits and that we are not just automating for the sake of it. Now, as we look forward, we will explore the challenges that organizations face when implementing the automation and the emerging trends that will shape the future of this space. Understanding the barriers such as resistance to change and integration issues will be crucial as we navigate these advancements. Additionally, we will be discussing the exciting developments in hyperautomation and AI integration that are poised to transform our operations. Challenges versus the future trends. It's essential to understand the dynamics that organizations face in this rapidly evolving environment. The balance between the resistance to change and embracing innovation is a critical factor in shaping the future of the work. One of the primary challenges we see is resistance to change. Employees often exhibit hesitance when it comes to adopting new technologies. This resistance can stem from various factors, such as fear of unknowns or concerns about the job securities, or it's crucial for leaders to address these fears through effective communications and training, ensuring that employees feel supported throughout the transition. Additionally, integration issues pose significant obstacles. Organizations frequently struggle to integrate new systems with their existing processes, which can lead to inefficiencies and frustrations. Smooth integration is vital for maximizing the benefits of new technologies. By investing in comprehensive planning and user-centric designs, companies can minimize these challenges and create seamless experience for their teams. On the horizon, we see exciting trends such as hyperautomation. This goes beyond traditional automation by expanding the automation capabilities across various functions within the organization. Hyperautomation enhances the productivity and efficiency by enabling the tasks to be automated at larger scale. Moreover, we are witnessing an increase in the AI integration across the process. As AI continues to evolve, more functions will incorporate its capabilities, leading to smarter decisions and improved operational performances. Organizations that adapt to these trends tend to gain a competitive edge in their industries. Looking ahead, the next discussion focuses on how to maximize the ROI with the automation. This involves making strategic, data driven decisions and implementing the right architecture to enhance the returns. We will explore how continuous performance optimization and tracking meaningful metrics can contribute to long term value, efficiency, scalability. Additionally, we will consider the importance of investing in the innovation and talent as part of treating automation as an ongoing journey rather than one time solution. Let's divide into these strategies for leveraging automation effectively. Maximizing ROI through automation architecture. When we think about maximizing our return on investment, automation emerges as a key player. It's not just about implementing technology, it's about making strategic data driven decisions that enhance our overall performance. The emphasis on importance of having the right architecture in place is a key. The foundation element is crucial for enhancing the ROI through the automation. When we design our systems with scalability in mind, we set ourselves up for a long-term success. It allows us to easily adapt and grow, ensuring that our investment continues to pay off over time. Next, continuous optimization of performance can't be overlooked. This involves regular monitoring and tracking meaningful metrics. By doing so, we can identify the areas for improvement and adjust our strategy accordingly. It's about creating a feedback loop that drives efficiency and effectiveness. For instance, by analyzing the data trends, we can uncover the insights that lead to the better decision making and operational enhancements. Long-term value, efficiency, and scalability are intertwined. The more efficient our processes, the more value we can deliver over time. This is where investing in innovation comes into play. By bringing in the right talent and technologies, we position ourselves to not only keep pace with industry changes but also lead in our respective markets. Moreover, it's essential to view automation as an ongoing journey rather than a one time solution. This perspective encourages a culture of continuous improvements and adaptability. It reminds us that automation isn't just a project to tick off in our list or adopting the latest tools. It's a strategic approach, data-driven decisions that requires commitment and align with the business goals as an ongoing investment. By identifying the right architecture to automate, continuously optimizing the performance and tracking meaningful metrics, organizations can unlock the long-term value, efficiency, and scalability of the automation. As you move forward, focus on building a culture of innovation, invest in the right talent and technologies, and treat automation as an ongoing journey, not a one time solution. Thank you for your time, and I hope these insights help you drive measurable impact to return on investment through AI powered automation. Thank you.
Yeah, and thank you very much. Thank you. And I see. Yeah, hello, Data. I saw you on backstage and just decided to pull you in. How are you? Your mic is
Yeah,
muted. Yes.
I'm sorry.
No worries. Yeah. Hello. How are
Yeah,
you?
yeah, I'm doing good, Ed. How about you?
I'm having fun. I'm having fun. It's a great event. Nice presentations. Some are
Thank
really
you.
fun. Some are just very, very technical and deep. So yeah. And where are you based, by the way?
I'm based out of North Carolina, in
Hmm.
USA.
Right. Okay, cool. And yeah, why don't we just start from our questions?
Sure.
Let me find some nice question for you. Let's go from this one. How do you balance AI automation with human oversight in QA?
How do you balance AI automation with the human oversight in QA? Yeah, sure. So basically, AI automation would be like we are making use of AI to help us in doing the automation rather than just letting the AI do the complete automation for us. Let's take an example of a scenario where we need to automate like certain functionality. When we given for some of the tools, if we given this requirement, it will give us a certain list of scenarios that can be automated, and some of the tools will even write the code for us. However, we need to make sure like if there is any exclusions that needs to be done, those needs to be taken out from the list of the things which are given out as an output. And also some of the web elements for identifying elements, like those can be the ones which are easy to be picked up, will be picked up. So we need to make sure like those are the ones which are not the ones which I mean, like let's say as an example, there is an web element which will be used by the ID. So ID is available, so the system takes the ID for identifying the element. However, sometimes it is little harder for Salesforce applications. ID keeps changing, so we need to look for a different DOM which will be used for completing the automation. So these type of certain changes we need to be doing in the automation. So definitely yes, AI will speed up this process rather than like writing the whole set of web elements. And we need to write the code, and we need to think of the scenarios, and sometimes we may skip some of the scenarios. So definitely AI will help us in creating all those scenarios, but we need to be oversighting those outcomes.
We're not there yet, people, so do not rely too much on AI, of course. When
Yep.
applying AI in DevOps, what is the biggest bottleneck and how did you fix it?
Um, I would say there are like it is not like a straightforward using the AI into the DevOps. There are certain cases where, let's say, I would like to give the user the privilege to run the environment whenever they need it. So AI will help me to just click on a button which will generate the environment for us, but there may be like backend issues, or maybe the environments are down, or the resources are not available. Those are certain things which we need to be looking into when the jobs are failed, or if there is any issues in setting up the environment. So these are some of the things which definitely needs manual intervention if there is any issues. But yeah, there will be like a lot of challenges like the resourcing and issues with the I would say the names. I mean, like let's say you want to use a certain name for your environment, the names may be already taken up, or maybe it is not, it is restricted in our setup. So those kind of things we still need to troubleshoot.
Absolutely. Great. And how do you measure ROI from UX improvements tied to automation? Any specific metrics?
I do not have the specific metrics for it, but I can give like a very good example. Let's say, uh, I mean, for certain companies, the UI is so bad. Sometimes we feel like opening the page itself would be like a so annoying, and feels like, okay, do we really need to work on this web page? So those, I mean, it may not. I mean, if there is no competition for that organization, we may feel like, okay, yes, I don't have an option, I need to work on this still. But if there is any competition, like people will definitely try to switch to a different organization. Let's give a quick example. Like let's say, okay, if you open I mean, I won't say like an bad design, but if you open Yahoo, I mean, Google search is like why it took over because of the good UI. And just assume like if you open Amazon in 1999, you won't feel the same experience as you are feeling nowadays. So these are some of the quick examples. I won't say this is the deal breaker, but this will definitely help give like the user best experience we are planning to give to them.
Can't say Amazon is my hero actually in design for
Yeah.
for the marketplaces, but it means I'm wrong because it works, right?
Yeah.
What's your fallback when AI predictions conflict with the team priorities?
When AI predictions conflict with the team priorities, I would say like try a different model. I mean, it's not like if you get an option, like, I mean, I have, I mean, real time examples too. Like, we are planning to create a design where I would like to get the user to use my product and they're using it for the very first time. We created like 20 designs and none of it fit into our requirements. We just went ahead and created new few more, and some of them seems like good, and we you took it and we enhanced it and make like customized to our to our users, and it worked. So it's like, it's not like you are just relying on the AI to create it. It is just like an helping hand for you. So definitely if it didn't fit, yeah, you can create a few more.
This AI actually creates the interesting situation now. We need to fight for the truth because, for example, with my kids, actually, they are teenagers, and whatever you say, they can tell you, "Hey, ChatGPT says differently. Go check out this stuff." And now I'm a buzzer, but I need to actually compete for the truth.
Yes.
Well, it's insane, but still, well, I need to keep up with that, really, really. And yeah, thank you very much for your answers and your smiles, energy, and the talk you gave uh,
Thank you.
to
Thank you,
us.
Nate.
Yeah, have a nice day, and we are moving to the break now, and we'll have. Let me check up with the. It's like almost 30 minutes, almost 30 minutes, and come back. We'll have Sachin Francis, right? Yes, with architecture lightweight mobile experience for the next billion users. Wow, I'd love that. But he is from LinkedIn. He knows about billions of users, probably. Okay, see you in 30 minutes. nice break. I hope you had some tea or coffee or lunch or something, or just few minutes of nap. I don't know. But we're back, and our next speaker, Sachin Francis, architecture lightweight mobile experience. Sorry, for the next billion users. Well, let's do it.
I'm Sachin Francis. Hope you all are doing well. Today, I'm going to talk to you about this topic on light apps. Specifically, how do we architect a lightweight app and how is it beneficial for the users and to the product? So, let's dive into the topic. So, before understanding how we can define a light app, we should understand why a lightweight experience matter to both the members and for the product. So, most often, our product users encounter low connectivity scenarios, and not all the global users are on extremely fast network. They may be on like 3G or like unstable connections, and they might be like traveling in a tram or a train, and they may not have proper access to the network or very spotty network. And a lot of users globally, especially on Android, would be using entry level smartphones, which may not be like fully configured with high end RAMs or processors, and may not have the best state of their batteries. And another problem that we have is that, let's say you have an app that's huge in size, that is usually a barrier to download. You see lesser downloads with more the app size you have, right? Also, the studies indicate that increasing the app size drastically decreases the downloads on the stores. So you also have to deal with diverse device compatibility issues, like the OEMs forcefully killing your apps in the background for extreme network consumption or the battery consumption or the processor usage or the RAM. And you also have to deal with users who are not getting good experience and you are not able to maintain that retention or repeat sessions from those users. So this is where the lightweight apps helps you or comes into the picture. Like, how can we solve all these challenges that we have today, right? Taking a step further, so let's see what is a lightweight app, right? So in short, a lightweight app will have a very lesser size to download. Say for example, on your app store, an app which has lesser than 10 MB of size can be classified as a light app in general. But it just does not mean the initial app size. So it also means that your app is not bloated with features that does not actually matter for the users. It also means that it's very responsive, like it does not use much of the processing power or the RAM, or it does not use battery so aggressively. And it also means that the app is very fast to download, to first load, to activate, and to use all the features in the app. And it also offers you a cached experience when you are in spotty network or no network scenarios. And it also means that your app should be like responsive and also offers like a very good crash free session rate. So these can be considered in general as like high level category classification, high level specifications that you can have for a light app. So this is not a fixed list of things that we should target for. It can be tuned around the product requirements and need of the hour. So let's see why the lightweight experience matters for the user, right? One, it makes it very easy to download. Like your app is downloaded in like a couple of seconds or like few seconds, right? So it gives a very positive impression to start with, and it also helps in better activations, and user is prompted to open the app and do the app activation. Which also means that if you use the very lesser resources, let's say you have an app which uses like very few MB in size, it's common for the user to retain the app than a heavyweight app which prompts user to go on and uninstall the app, which if he's really not interested in that. And it offers a very faster experience and very responsive experience, and it is actually well suited for the on-the-go use cases of like transit or like rural travel. As mentioned, it's very effective in the low quality networks and it uses like very low resource usages. So basically it does not harm any day-to-day regular activities of the user that he does on his smartphone. And it also helps him with all the core functionalities that the product is offering uh, without any issues. So now we have seen why does it matter for the users. So let's see why does it matter for the product. As we said, so it has an improved download and activation rate. So it helps with the app activation funnel, which means more installs and faster activation. Also, we will go into this later. It also helps in a faster go live time, which means that much lesser time to develop new features. You don't have to go through the app release cycles of your on the app store. So it helps in saving a lot of time, especially when you have some bugs or crashes, or you have to iterate on through features. And it can also potentially help develop once for all the 3 clients or all the 4 clients, we can say desktop, mobile web, iOS and Android. And it can also help with market penetration in the underserved or the emerging markets where your product was not originally intended to be launched at. So it can serve as a good experience for those regions which you cannot ideally target with the full versions of your app. And it can also help as an upsell platform where you can get the users moved on to the bigger version of the app. So, and it can also help you with a lot of experiments. It can also help you help the product with better brand partnership given the low network usages and the size and resource usages. So you can come up with partnership with the OEMs for pre-bundling as well as to be on some exclusion list of like for skilling so that you can get better notification sessions, etc. and so on. Okay, so we talked about lightweight app in short, but I just want to emphasize here that lightweight does not mean that we are not offering all the features that is needed. We will still continue to offer all the features that are critical to the users, but our aim here is to reduce the friction, not the functionality. So for each and every feature, we should see what's the value that we are adding to the member as well as to the product, and should not be for anything that is complex. So we should always have this thought in the mind. Okay, what value is it adding? So it's all about the prioritization. It's never about removing any features from your product. So how can we build lightweight experience, right? I'll try to focus here mainly on Android, but it's applicable to all the clients that we have today. So I would classify it into 4 different ways of building lightweight apps. First one, you can build an app fully native, which is very clear, straightforward. You can build them as progressive web apps, and you can have some hybrid version of the app, and you can also have some server-driven UI. So these are the 4 approaches using which you can build native apps. We will go in detail through each of those category and see like how does it help and what are the pros and cons. Okay, so let's start with the fully native version of building lightweight app. So here it's very clear and straightforward. So you build all the features natively as you build any Android app. You stick to a design pattern and then implement the features, whatever is needed there. So the advantage here is that you can offer the users like very slick native user experience, and even on like spotty or low internet scenarios, you can have some pages locally which can be served with some experience or caching. So that scenario can be handled to an extent. But the cons here is that so it is very difficult to maintain a small app size. As and when you need more features, you start increasing your app size because you have to build all of those natively. So one way to do this is dynamic features, but still you end up using a lot of resources on the phone, and the initial app size will still be higher as you go ahead and build more and more features to the app. And hence, you will be forced to trim down your features on the light version of your app, where you will essentially have only those features that are very critical. So which means that it's not so product friendly. So because you cannot add a lot of value with limited number of features. Again, you are also limited by the velocity of development, because you have to go through the app release cycles for each and every iteration that you have to do on the product. So you have to go to this publish the app and get it approved and ramp the app on the Play Store. And if there is any bug, or if you have to iterate on it, or for any crashes, so you still continue to go through the same process again and again, so which takes a lot of time for the feature iteration. So the next approach is server driven, right? So server driven, as the name sounds, instead of getting the data to render the screens natively, so what we would have here is that you would actually get the screen as such from the server. Consider it as something similar to like SSR, server-side rendering, where you get the HTML from the servers. But here it may or may not be an HTML. It can be JSON, or it can be an XML, or it can be like something like a virtual DOM that you get from the server. And clients would have a parser which transforms this UI component dynamically into views on the native client. So this means that there should be some code written on the client side which can take this as input and then convert all of them into the views. So it may not be like, the size of the app may not be so small, but it can always stay at a definitive value. So given that all your whenever you add more and more features, it's all done in the backend and not in the clients or in the front-end server. So here, as again, the views are all native, so the slick user experience, the faster you get the faster release velocity, because you can just build all your features on the server once for all the clients at the same time, and you can also maintain a stable app size. Now, coming to the cons of this side, right? So even here, it's challenging to maintain a smaller app size, because you need to build those parsers and custom rendering framework for a lot of different types of view components. So to keep the app size very limited with those is challenging. Two, as this process of rendering has become more resource intensive, so you will also end up in high network usage, because you're going to send a lot of data through the wire. And so high network usage and processor usage. And it's also not suitable for scenarios like the prefetch, where you can offer some sort of where you can get some sort of an advantage in your page load times, because you will have to like prefetch pages in advance, which is a lot of data. So those use cases may not be ideal in this thing. And again, the architecture and debugging also becomes much more complicated, because now your UI logic or the rendering logic is actually distributed between clients as well as your front-end server. So that makes it a little complicated. So let's see the next approach, hybrid apps. So hybrid apps would mean that you will still have some of the views natively, right? Say for example, a splash page or the login page or the error page or the pages that you need interaction with some, let's say, biometrics or your contacts upload or permission requester or the file download. All such things you can build natively, or wherever you feel it's critical to offer a native experience can be built natively, which means that we have very limited set of features which will be built natively, so that your app size is very minimal, and all other features would be can be implemented in a web view or a trusted web activity or a Chrome custom tab, which means that you will have a front-end server, and from the front-end server, so you can use some architecture where you either use server-side rendering where you get an HTML or something on those lines. So again, the advantages here, as you develop once for all the clients, it's very easy to keep the app size in check, because you have very limited number of native views, and you can easily implement caching and prefetching. We will see how that can be done so easily, and then again, your release velocity is very high. And the cons here is that, so you have to put an extra effort to make sure that the differences between your native and the views from the web are kept very minimal, so that you get a good user experience in transition between the native and the web user experience. So let's see what's the next approach is. This is progressive web apps, or PWA. So PWAs essentially use service workers. So what this would mean is that, let's say you have a web app with service workers enabled. A lot of you would have already seen this or know this. So you go to some website and then you get this prompt, add this page to home screen, right? So what essentially happens is that a shortcut is added to the home screen with an app icon. When you click on this, you always go to that particular page, right? So this is done through service workers. So again, here you have the advantages of like developing once for different clients, and it's easy to implement in caching and prefetch. You have the faster release velocity. So the main problem that you have here is the discoverability of your app. So here the apps are not listed in an app store, right? So which means that your organic installs as well as your paid marketing campaigns are not going to work well. Why I say the paid marketing campaigns are not going to work well is because, let's say you promote your website on some platforms like Facebook or Instagram, right? So those links open inside a tab inside those apps where the service workers won't work, which means that the add to home screen, you won't be able to do, users won't be able to do the add to home screen. So your product marketing team is not going to like that, right? So also you are limited in or you're going to get limited in the audience, and there's no native experience, and there can be potentially some limitations in accessing native features like biometrics, and this limitation can vary between devices as well as platforms, like between iOS and Android. So it becomes a little tricky, and you have to deal with a lot of edge cases when you are trying to address all your user base through the progressive web apps. And you will also face challenges with your notification deliveries. So a lot of people who have developed progressive web apps has been struggling with getting a good delivery rate for their notifications. So that's also a challenge, which means that your notification-driven sessions will be heavily impacted. So now let's take one example of dive more into like how, so from all the 4 categories that we have seen, so the hybrid approach makes more sense to build a lightweight app. Of course, all others are still valid good options for its own reasons, but let's see how we can build a hybrid lightweight app. Okay, so as I said earlier, so it's a mix of like native and web views, right? So your app would have all the native views, and there will also be a web viewer activity, right? And the web viewer activity hosts the web view, which has service worker. So service worker usually helps in maintaining the caches of the page, right? So let's assume, okay, when do we need native activities, right? Say for example, the splash, the login, or to maintain the cookie store, or your networking layer, your download listeners, or your interaction with biometrics, all such things. So you can build a native way. It's not just limited to this. So wherever you would like to have a native view, so you have that. And then you have a web view. So you just transition to the web view whenever you need it, when web view or activity, whenever you need to load other features which are like dynamically driven from the front-end server. And what the service worker does here is that for service, let's assume that this is based on a server-side rendering architecture. So this means that the service worker makes a request to the front-end server, which would give you back an HTML, which will be displayed in the web view. It also makes sure that the cache, let's say in this example, the primary cache is updated with that particular view, right? So in parallel, you can also make subsequent requests to the front-end server to cache additional pages and put it into your secondary cache. So whenever a user is supposed to navigate from one page to another page, right? So you first check whether it's available in the primary cache. If it's available in the primary, if it's not available in the primary cache, okay, you can serve from there. If it is not available in the primary cache, you can check the secondary cache to see your data is there. So that way you can make, this is how the prefetch can work. Like you already have prefetched that page, so you can just load it from secondary cache almost instantly. So this would mean that you have some sort of a caching mechanism as well. And you can also define like what should be the expiry of caches in each of the stores. Say for example, let's say you navigate from one page to another and then come back to the previous page, right? So you want to maintain the index or the cache, the position of wherever the user had scrolled to. So the primary cache helps with that. But let's say you have your timeout set to like 5 minutes. So user has navigated to another page and comes back to the original page after 5 minutes. This time your cache is expired. You can do a force delete of the page. So you can have all such logic with the combination of cache here and with service workers. So you would also have a backend server. So the backend server does nothing, but helps you with anything other than your front-end pages. Say for example, your auth, or let's say you want to upload the address book to some store, right? So backend server helps you with that. So which would give you the auth and other view data, and the front-end server gives you the HTML and assets. And for all your notifications, which will be handled through the Android app, so you can have something like a Firebase Cloud Messaging or any other notification platform that you would like to use. So this is an architecture using which you can build a hybrid lightweight app. So now we have seen how we can build a light app. So let's see what are some design considerations that we should look into while building a light app, right? So the first and foremost consideration here is that you have to keep the app size in check. So how can you do that? So one, the dependency analysis. Whenever you build a new feature or whenever you try to build a light app, so you have to make sure that you do a proper dependency analysis for all the features that you're trying to build. You should not be dragging in a lot of dependency that adds a lot of size to your APK. Make sure you define a threshold for your page size that you try to render from your front-end server. So define it at a particular threshold, like for example 50 KB. So like if you choose that as a limit, so make sure that it never for any of your feature it never exceeds that particular size, so that your app works on almost any network, whether it be 3G or 4G or spotty network. App size monitoring for each and every commits that you make sure that you have an app size monitoring check in place, and make sure that it does not go beyond a particular threshold of like it might be a few bytes or a few KBs. And work with your product team to categorize the features. So deliver the features that are essential to the users and are beneficial to the users over bloat, and or also beneficial to the product or beneficial to the product, right? Now, static assets, right? To choose your static assets wisely. So bundle only the things that are like critical. Try to download them on the fly when needed, or do not like pack in a lot of I18 strings where it is really not where to support the regions that you are not really targeting, and so on. And try to make use of features like dynamic features if you absolutely cannot restrict your app size. Then use the proper code shrinking techniques, lazy load or prefetch pages, so that your data, your pages are rendered fast, and make sure that the data that you fetch from the network is limited, so that it's again loaded fastly. Also define a threshold for everything, whether it be app size, whether it be changes in your commit, whether it be related to delta of the app size that you're adding in each commit, or whether it be the page load time or whatever it be. So define thresholds for each and everything and make sure that you follow them. And network simulation for each and every feature that you build, make sure that you test it on different network speeds. So you can use any network simulation tools to test it out and see how the experience is and try to improve on each of the pain points. Metrics monitoring. So make sure that the metrics are monitored independently for the different device categories, whether it can be like an entry-level devices or like high-end devices, or it can also be based on network category, whether it can be like slow speed or 5G network or a Wi-Fi network, so that you have the classification of your data on tracking data on each of those networks, and then monitor them carefully and define thresholds in which you classify it as a degraded experience and always make sure to follow up on that to offer the users a right product experience. Let's move on to the conclusion. So what we have talked now is all about light apps and how it helps. So it can help you unlock a lot of user base from the low-end devices and also those who does not have access to good quality network. So it opens door to a lot of users. So it can significantly boost your activation and engagement and retention and the sessions and follow-up sessions from your on your product. So it is also a platform for experimentation because you can easily and quickly do experiments because everything is sort of server driven. So unlike on the native app experience, say for example, you try to do a small experiment. Let's say you want to try to see, okay, you change the color of your buttons on this page to some other color, and you want to see how it works, right? So it's just like a couple of lines on the server, and then you just commit and deploy the change in the same day, and then you get the metrics in like 1 or 2 days, and then in 3 days you are done. But consider that you are doing it on the native clients. It would easily be like a week or 2 weeks of effort or end to end to see whether it works or not. If not, you may also have to end up reverting some changes, or let's say you introduce a bug in the process, it again adds to the timeline. So yeah, that's exactly the last point. It increases the development velocity. So it helps the users, it helps the developers, it helps the products, it helps the metrics. So that's all about light apps. Thank you so much for listening to me. I hope this is helpful for everyone who is watching this. Bye.
Yes, it was great. Thank you. Thank you very much, Sachin. And next speaker, Manoj Surandi, leveraging Gen AI for customer support. That's complicated topic. But let's all together dive there, and finally, probably we'll find out how to do it properly. Manoj Suridi from Uber, I guess. Yes, from Google. Uber. Let's go.
Hey everyone, I'm Manoj Reddy. I work as a staff software engineer at Uber. I lead the customer support automations and generative AI chatbots team. Today, I'm going to talk about redefining customer support with generative AI, diving deep into the architecture that provides scalable, intelligent, and human-centric experiences to our customers using generative AI. Let's answer the question why this matters. Customer support today is undergoing a tectonic shift. Traditional workflows not only have long queues, rigid scripts, and delayed resolutions, but they are often associated with a lot of cost. What if we could solve 70% of customer queries instantly with context, empathy, and precision? Generative AI makes that not only possible, but also practical. Today, I'll walk you through how we are reimagining customer support systems with Gen AI in a more responsible, scalable, and meaningful manner. Let's talk about the evolution of customer support. Previously, the basic fundamental systems of customer support consist of IVR, static FAQs, and ticketing systems that provide the overall customer support with agents behind these systems. Then there is an advent of decision tree based chatbots and automated responses. But the problem with these kind of chatbots is they are very robotic and they cannot pivot if there is a different intent that is passed by the customer. Later on, we augmented this with ML models or natural language processing models, but they could only solve this particular problem to some extent. Then there is an advent of generative AI after ChatGPT and other large language models have launched, and there has been an explosion of these kind of generative AI models in the market today. Generative AI not just is about better answering, it's about fundamentally a different interface that could understand, adapt, and learn continuously and provide effective resolutions to the customer support queries. That provides a more blissful experience to the customer. That is the overall goal of this generative AI solutions within customer support. Let's initially understand a scenario where a customer is interacting with our systems. This will allow us to visualize the next architecture which we'll be going through so that you can dive into the architecture in a more contextual manner and you can draw parallels on how this experience is being solved. Let's say the user asked a question. Let's take an example. The customer is asking about a refund eligibility. We will retrieve the standard operating procedure after we receive the customer query. Now the standard operating procedure can be stored in some Vertex DB or RAG solutions. This could allow you to pinpoint which all standard operating procedures match the user query. Then we retrieve the overall history from other systems, such as, let's say, the user is reaching out regarding an order. So we'll retrieve the order information, the tone of the user, based on which we'll respond to the user. Using all this information, now we'll formulate a response using an LLM. LLM generates a response, but can we send it directly? No, not really. We need some kind of a guardrail which ensures that the overall LLM response is compliant with the company's policies. So what we do here is basically filter out any identifiable harmful or offensive responses. We make sure that there is no data leak. We redact any personal information from this response and make sure that the response is also using the correct language which is set by the company. Then we'll deliver this particular response to the user. Sometimes there may be cases where we don't even want to respond to the user. We just want the user to be transferred to a human agent. In those cases, we'll respond to the user in a more empathetic manner, mentioning that we'll be transferring you to a human agent and then we'll transfer it there. So these are the overall scenarios we'll be discussing. So make sure you keep this in context when we are looking at the overall architecture going forward. Now let's zoom into the architecture here. So this is a exploded view, but I have made sure that I'm not providing too much of information. So I consolidated some of the layers here in order to ensure that the right message is communicated. We have a bunch of systems here. Let's go through one by one based on how the user query is flowing. Now on the left side, if you see, there is a client which can be chat or voice. This provides an interface for the customer in order to provide a customer support query. Now the query flows to our API gateways. These gateways ensure that the user is authorized and the user query is basically rate limited so that we are not subjected to any spam queries. And also our systems are load balanced, ensuring that we provide less latent and ensure that our systems are completely available to support the customers. Now the user query flows to our orchestrator. Orchestrator is the heart of our ecosystem here. Primarily, it interacts with all the services upstream and downstream in order to ensure that the customer support query is properly served. It plugs into a lot of the systems downstream in order to retrieve the context, retrieve the embeddings from the RAG layer at the bottom. If you see, there is an embedding and retrieval service. This service is responsible for retrieving the overall vectors, converting it into the right request and response formats, and it provides it back to the orchestrator. And also we have prompt templates, which templatizes your prompts so that a lot of the embeddings that are passed down from the orchestrator to the LLM gateway are properly formatted, and you have a templated response that is filled with the retrieved document data as well as other context that you fetch from the downstream services, let's say order service and all the other services which provide you the history, the current state of the order, and whether you can refund the order or not, and all that information. Now, the action executor's responsibility is to ensure that specific actions are executed. Let's say you have decided that you have to provide a refund to the user. This action executor will be responsible for orchestrating the action execution by plugging in the right information by talking to the downstream services like the ID formatting, the overall request construction for the action to be executed, and etc. Queuing those actions as well, and all this information. Now, once we have retrieved the response from the LLM gateway, we have to run it through a response moderator, which ensures that the response as a whole is compliant with the company's response standards, and then we send it to the customer. The conversation store at the bottom maintains the conversation history from the chat or voice client. This ensures that the orchestrator is context aware, so that when passing the LLM the overall customer query, it also passes the context so that the LLM responds in a more contextual manner. That, let's say, if the LLM already rejected a refund and the customer is insisting that they receive a refund, passing the previous whatever previous queries and responses that we have sent to the customer would ensure that the LLM responds in a more empathetic manner, acknowledging that the customer wants a refund, but according to the policies, we are unable to refund the customer. So in that scenario, the response acknowledging the previous query and the previous response makes it much more contextual and also connects with the customer in a more effective manner, providing a much more blissful experience. But it may not be the case in this scenario because we are returning or rejecting a refund. But providing this sort of contextual and empathetic responses would always enhance the customer support experience. Now let's talk about the trade-offs to consider. This isn't a plug-and-play system. As you are architecting such kind of large-scale transformation, you are often associating this with a bunch of trade-offs. Let's go through a few. Model choice. Do you want to choose a large-scale model or a smaller model? An open source one or a closed source one? Do you have the right infrastructure to host open source model? Or do you want to use the publicly available APIs, and publicly hosted models in order to use it? How do you ensure that you cache your responses in order to save some latency implications? Or do you want to pre-generate some class of queries? How do you want to solve that? How do you prevent hallucinations while you are still sounding natural and empathetic? How do you ensure that your responses are right and within the guardrails set by the standard operating procedure? How do you build trust with the customer while still ensuring that you are using some of these automated models to answer the customer support queries? There are other compliance related information like PII redaction, hallucination mitigation, etc., which I have been quoting some examples as well before. And the overall cost associated with this, like how do you minimize the token usage and the caching logic, which we were discussing initially. So all these trade-offs would comprise or together help you in architecting the right system, and it may differ from use case to use case. Now let's go through some of the techniques that can help you in taking these decisions effectively. Majorly feedback loop and learning. Make sure your system is becoming smarter over time. Majorly use a human in the loop technique where you can ensure that the responses from your customer support bot or the generative AI bot is always curated by a human in between before sending it to the customer. This could ensure that you're sending the right information when you are initially developing these models. Later on, you can automate it using some of the response moderators, which we have spoken in the architecture diagram. But initially, using a human in the loop would always ensure that you are providing effective responses and also ensuring that you would flag any nuances, hallucinations, and the overall tone differences effectively. And these edits can be logged and fed back into the system using various prompt tuning techniques or fine tuning your models in order to ensure that they respond effectively as mentioned by the agent. And also prioritizing user ratings to make sure that your responses are right for a specific scenario would allow you to take the right decision in order to tune your prompts effectively and make sure that they are working at scale when you are interacting with the customer. The next item in our list is guardrails and response moderation. I have been reiterating this item again and again because this is very crucial for designing the right customer support architecture. The first thing is safety. Our system should be effective in detecting and filtering out harmful, offensive, and violent content because this is crucial for providing a very blissful and empathetic response to the customer. Protecting your prompts against data leaks is very crucial for protecting your IP as well as the overall standard operating procedures so that you are not subject to any prompt injection attacks or your prompt is not leaked into the system so that your customers are or malicious users are circumventing some of these guardrails, etc. So ensuring that your system is resilient to such kind of attacks is very crucial while designing these systems. Next is policy compliance. The major standard operating procedure should always be followed before responding to the customer. Ensuring that the industry regulations and legal mandates are followed by the LLMs is very crucial, and this is where the moderation step comes into place, where it filters out any responses which are not adhering to such kind of standard operating procedures. And majorly contextual responses are very foundational for customer support. So when you are providing the responses which are much more contextual, like let's say the refund scenario where you are saying that you are unable to provide refund due to ABC reasons, being very relevant and coherent to that particular response or customer support query using the various information that are factual in your system, such as order history or the age of the order or the overall amount that you can refund to the customer and things like that. So a lot of these scenarios would involve a lot of context which should be factual, and that those facts should be adhered by your LLM model. Next item to consider is evaluation and monitoring. As you know, you are dealing with a very large prompts, and a subtle change in the prompt would always lead to a very drastic or sometimes a huge shift in the response quality or response itself. So ensuring that your prompt changes are going through the right set of guardrails before they are in production ensures the right responses are being sent to the customers. So you can use labeled golden data sets to evaluate your prompts through CI/CD pipelines in order to ensure that the prompt quality is always maintained and the response qualities are maintained. Majorly, there are two different techniques which we follow. LLM as a judge technique, where we use a very large language model that is benchmarked for quality and use it as a judge while evaluating the responses for a specific prompt. So the judge prompt also creates a response and compares it with the response that is generated by the production models using the same prompt. Now, the larger model compares both these responses and ensures that the same level of quality is maintained. The evaluation prompt can be much more resilient, where it is checking for all the guardrails, all the compliances, etc. So this is something which is a very effective process in ensuring that your responses are right before your prompt goes into production. The next set is human in the loop evaluation, where you can use humans to evaluate that the responses are right. This is always effective, where we could have better detection of nuances, intents, and tone, as well as like identifying any hallucinations that can occur when using generative AI models. Also, you can refresh this responses from the human in the loop evaluation to update your LLM as a judge evaluation models so that you are having a constant feedback loop in your evaluation pipelines as well, so that this will be very effective in making your system resilient over time. And this again comes down to how we have called out that your system should always be smarter and evolving at every point of time. And this is one of these steps which we should follow. Also, sampling these responses and alerting the right systems when there is a deviation from the human in the loop evaluation versus LLM as a judge evaluation, or else like the LLM as a judge evaluation itself is flagging certain prompts not being right. Having these alerts on these deviations would allow you to detect the degradations or regressions upfront. So that is something which we should always ensure that we are monitoring these responses and prompt changes while designing a generative AI system like this. Now that you have designed an effective customer support system using generative AI, what's next? How about instead of customer reaching out to you, your systems detect that a customer might be facing a grievance. So you can reach out to the customer to check whether that is the case. Won't it provide a very good experience to the customers? Yeah, it provides a very good experience, but it is also associated with the cost. But providing a very good experience to the customer and prioritizing the customer would always be a effective method for a long-term growth of your company and ensures that your customer stays with you for a longer time. Also, using a variety of interaction methodologies, not just text, but also voice, images, etc., could allow your systems to gather as much information from the customer as possible and help you in providing the right responses in a more contextual manner. The other optimization you can do next is creating smaller specialized agents so that they are fine-tuned to a specific issue type or a specific subset of issues. This allows your models to be faster, smaller, and also cost effective. And also these models are not scouring through a bunch of information, so the hallucinations are less and they are very effective in responding. So these are the next items you can look at. And as the LLMs are evolving, so must your systems. So it is not about one model, it is about an intelligent orchestration. I want to close this talk with a set of key takeaways. Primarily, you should always build these systems to gain customer trust and always ensure that you are solving the customer support queries in an effective and contextual manner. And you are not just yet another bot who are always accurate but not acknowledging a customer support query or acknowledging the customer grievance. As we are always talking about in this particular presentation, your system should always be evolving or learning. This can be from a human in the loop evaluation or from a bad rating from the customer or any of the internal systems, so that you are providing the same level of quality throughout your interaction with the customer. Keeping human in the loop to ensure accuracy and response quality is also very crucial in the initial stages, because it allows you to assess the quality you are providing to the customers and also make sure that you are going through the right channels to filter out any harmful responses. This should also be followed for any prompt iterations so that you are providing the same level of quality across all the iterations within your prompt, because your any subtle change in your prompt may drastically change the response quality. So always ensuring that you are going through the right channels to filter out or ensure that your prompts are evaluated is very crucial. With that, thank you for listening to me. I would love to hear your questions and experiences. I also wanted to give a huge shout out to Napkini and Excalibur. They have been very helpful in designing all the illustrations in this presentation. Thank you.
Thank you, Manoj. As always, great presentation, very technical, deep, and very kind of experiential. And our next speaker is just a second. Yeah, that's correct. Thank you. Sorry. Turjan Rayan Choudhury, AI architecture patterns for next GS applications. Let's go.
Well, hello everyone. Welcome to Software Architecture Global Summit AI Edition. I'm really happy to be here. Hope all of you are having a great time as well. This session is on AI architecture patterns for next generation applications. I will be presenting this session. I am Turjan Rayan Choudhury. You can reach out to me or know more about me at this LinkedIn. You can scan this for my LinkedIn profile. I am currently working as a global lead platform pre-sales at a Big Four consulting company, but I am at heart a cloud architect. I advise on IT strategy, and more recently, I have full-fledged gone into the world of architecture, AI architecture, and especially Gen AI architecture. This is a disclaimer slide. This just tells that this is my opinion. I'm not representing my company, the company I work for, or any other institution in any way. This is basically what I've learned on my own, and I'm sharing this in the interest of an open community approach. The overall agenda is very simple. We will start with some context setting. Then, because it's an architecture summit, obviously we cannot go any step further without just kind of telling everybody about architecture. Then we'll go to the meat of the session, which is on AI architecture patterns, followed by some agentic AI, just a little bit sprinkling some agentic AI, and finally some closing thoughts. Without much ado, we have a lot to cover. Let's go straight into some context setting. You can see that today there is a craze in AI and Gen AI. The kind of money that is being put into the Gen AI ecosystem, right, especially startups by investors, venture capitalists, is crazy. Just in the first 3 quarters of 2024, we have pumped in more money than the entirety of 2023. Who is this money going to? Some of the companies that we know about is OpenAI, Sam Altman, XAI, Safe Superintelligence, Anthropic, Mistral, all of them. Why? Why is investors spending so much time? Because based on some of the reporting that is coming out in the market, some of the AI companies are making an ARR, annualized revenue, of $30 million 3 times faster than SaaS companies. So the top AI companies are actually growing faster than the top SaaS companies. So there is a lot of, let's say, interest and excitement in the investor market about Gen AI. If you take a look at OpenAI, this becomes very clear. Till 2023, their revenue was $1.6 billion. In 2024, it is $3.7 billion. So they grew from 1.6 to $3.7 billion in 1 year, which is unheard of. In 2024, OpenAI had closed a deal of $6.6 billion and their valuation was $157 billion USD. Now, with this new infusion of $40 billion by SoftBank and other investors, OpenAI is valued at $300 billion, 1/3 of a trillion. Just a startup, right, in a way, which has been around for 10-15 years, now valued at 1/3 of a trillion. So at one end of the spectrum, we have so much excitement, hype about Gen AI, but are enterprises getting the required ROI on their investment? As an enterprise, if you are representing an enterprise, what is happening in this enterprise ecosystem, right? That is what I want to understand. One of the surveys that was done by one of the Big Four consulting companies said only 34% of CEOs said they have got the required ROI that they expected based on their Gen AI investment. That means 66% did not. So out of 100 CEOs, 66 CEOs are saying, no, I'm not getting the kind of return on investment that I expect from the investment I did in Gen AI, which is very scary, right? If you understand me, we cannot just keep putting in money, right? With that, all of the hype, we need to make money for our stakeholders also, right? So all of this investment has to make sense somewhere down the line. So that's why every AI business today has this dilemma, right? Okay, they want to adopt AI to stay competitive, to stay ahead of their competitors, but at the same time, they're a little hesitant, right? How to approach it, right? Are they following the best practices? How should they scale AI? What are the things that they should invest in? What are the things that they should stay away from, right? They don't have a lot of clarity. And where there is a lack of clarity, architecture is the foundation that provides that clarity. So with this, I will end section 1 with this key takeaway that enterprises are struggling to get the most out of their GenAI. No matter how much hype we have in the startup ecosystem, right? No matter OpenAI is getting a one-third of $1 trillion valuation within 10-15 years of existence, doesn't take away from the core, which is enterprises are not getting what they need from GenAI. And my job today would be to explain and kind of help encourage you think that yes, with architecture, with correct architecture patterns, if we follow them, maybe some of this apprehension that the enterprise CEOs have will go away. So this is section 1. Section 2 is a little bit about architecture. Again, it's an architecture summit. Why do we need architecture? What is architecture? How do we go about architecture? So one of the fathers of architecture, Grady Butch, right? He defines architecture as a set of significant design decisions that shape the structure and behavior of a system. Again, this is a little complicated sort of a definition. So I go to this definition, which is from Martin Fowler. He says it is a set of design decisions that must be made early, right? This is very important. You have to make these decisions early in the path so that if you don't make these decisions early, you will have to pay the price later. If you make these decisions early, if you make the correct decisions early, then you don't need to pay the price later. Same thing is being said here. Architecture in the field of software development are decisions that are hard to reverse. So hard to reverse, and you have to make it early. Why do you have to make it early? Because it is hard to reverse. If it was not hard to reverse, we could have made it later. What are some of those decisions? So let's say take an example of whether I should go with a synchronous API based communication system, or should I go with an asynchronous messaging system like RabbitMQ or Kafka. That is a design decision that has to be taken early on, because if you kind of build entire application all synchronous sort of communication, then after 6 months, if something goes wrong and you want to kind of revert back, right, to the old way of working, which is basically asynchronous, let's say you want to go back to asynchronous, it will take a huge investment. That's why architecture is important from the perspective that these are decisions that will help us understand what to do with your application. But at the same time, we have to be very, very clear on what those decisions are. They cannot be reversed very easily. So we need to be very correct, and we need to take the correct decisions for the best of our application or business. Okay, so if that is architecture, if it is a set of decisions that has to be taken earlier, and we will help discuss some of the decisions for GenAI applications, what are architects? Architect is nothing but somebody who has a holistic understanding of the system and kind of sees the system across different perspectives. So here one person is saying this is a circle, other person is saying it's a rectangle, but as an architect, you need to see the holistic picture, and you need to say, no, this is not a rectangle, this is not a circle, this is a cuboid sort of a shape. So we as architects need to provide a good sort of context to the system. But is architecture important? Does it matter? So I like this quote: if you think good architecture is expensive, try bad architecture. Because bad architecture over time will slow down the ability of your customer to compete. Initially, it might feel very sexy or very, let's say, agile, right? Because I'm just building everything on the fly. I don't need any architecture design decisions. I don't need any architecture review board. I'm just building whatever I want. But over time, it will slow down your ability to compete, right? What do I mean by that? So if you see, what we are trying to show with this no design line is that if you don't do any sort of a design, yes, initially you can start early, right? Because you are not doing any decision, you can start delivering features very rapidly. But over time, you will see, because there was no architecture, there was no building block, you did not take the correct decisions, your ability to keep on kind of sharing features, right? Keep on delivering features will over time exponentially decrease, right? Because your foundation is not strong. Whereas at the same time, if you have a good design, if you have a good base, then what happens is that even if initially you take a little bit time, because you have to build an architecture design document, you have to build a solution document, but over time, because you have invested in taking those correct decisions, thinking about those decisions, thinking about the pros and cons, the trade-offs of those decisions, over time, your thing improves, right? So you start delivering more features at an exponential rate, or at least at a linear rate, because you have invested the time and effort in setting the foundations correctly. So again, the key message I want to take away from this section is architecture is important. It matters because without architecture, if you completely remove an architect or an architecture from this perspective, from the solution overall, from the design phase, then what happens is you start building stuff very early, but that is not very scalable, right? That might not be repeatable. It will break over time, right? It might not be able to scale as much as you want to. And over time, your ability to deliver features for your customers, right, which is what we all want, slows down. Perfect. So with this too, I kind of mentioned what is architecture. And at the same time, I also kind of mentioned in section 1 that there is a problem, right, with enterprises not getting. So what I'm trying to say here is that I think there is an investment that enterprises need to make in this concept of an architecture pattern. So an architecture pattern is nothing but a kind of a reusable blueprint, right? So they are reusable, they are tested, they have stood the test of time, they have worked in different scenarios. Obviously, every architecture pattern has a context. It is good in some cases, it is not good in some cases, but it is something that an architect has developed, tried out, and once he has seen this thing work in multiple places, he has created a mental model of what works and concised it or kind of packaged it into this architecture pattern. These are the architecture patterns that I will now focus on, which is very specific to the AI space. This is based on some of the learnings that I have in my day-to-day job, and I used this article from Martin Fowler extensively because of the diagrams, because of the explanation. Very nicely done article. But the most important thing before I start on this, explaining some of these architecture patterns that I want you all to think about is, why are we doing this? This is very important, right? Why do we need architecture patterns? As I said, I kind of explained why we need architecture overall. Without architecture, it's very difficult for us to compete at scale over time and keep on delivering features. At the same time, we also know that Gen AI return on investment, our CEOs are saying it is not kind of matching their expectation. So my thesis is, if we invest in tried and tested AI architecture patterns, things that have stood the test of time, right, which is recommended by experts, which seems to work, then what we do is we take them as blueprints and then we share across the enterprise. And we encourage everybody in that enterprise to kind of use those blueprints and those architecture patterns as the foundation of what they're building. In this way, I feel everybody will be able to get the most out of this thing called Gen AI. They will do the correct thing. Everybody will follow the architecture pattern that we want the enterprise to follow. And hopefully, if this happens, if everybody follows some of these architecture patterns at scale, then in a later survey, our CEOs finally say that yes, they're getting the ROI, right? So in a way, architecture is important, architecture patterns are important, and in Gen AI space, which is an evolving space, it is even more important. With this, let us now first go to some foundation patterns. This is a very simple pattern. This is called the direct prompting pattern. This is what we do with ChatGPT. We go to the LLM and we start typing. We say something and it comes back. This is a complete direct LLM access. This is good in some ways, but at the end of the day, it is not enterprise grade, right? Because there is no extra awareness of the data, right? It only knows what it is trained on, right? The LLM can only answer based on what it is trained on. It doesn't have any context of your enterprise data. There is not a lot of security and reliability because you have not put in any guardrails. You can ask something very wrong. The LLM can hallucinate. Many things can happen. So this is a very, very, let's say, premature pattern, but I still wanted to have it because this is the way we today use some of the AI tools, chatbots, right, without knowing about it, most of the cases. And this is a B2C pattern, right, business to consumer pattern. So this is not an enterprise grade pattern, but this is still a pattern. This is another foundation pattern that I wanted to focus on. This is called evals. Many people don't do some of this, right? I work with a lot of architects. Many of the architects will start, okay, I will do query re-ranking, I will do reflection of agentic. No. But eval is basically the way for you to understand how your Gen AI solution is doing based on your expectation. This is very important because with traditional Deterministic solutions, you could do unit test, integration test, right? 2 plus 2 equal to 4. But with Gen AI, you cannot do this, right? Because these are non-deterministic, probabilistic sort of solutions. In this, traditional testing will not work. You can use some of this LLM as a judge model. You can put a little bit of human review also in the middle. Obviously, we'll need that. But it is very, very important for us to acknowledge this pattern and follow this pattern. We need to invest a lot of time and energy in writing very, very good evaluations to see if our LLMs are actually doing what we want them to do, and if any changes in our architecture or our design is improving the performance of the LLM. Otherwise, we'll never know, right, whether it is improving. Evals are the only way for us to see whether it is improving. And FYI, evals are not same as benchmarks. Benchmark is a different thing. Benchmark is kind of like an industry standard. Okay, for benchmark X, Llama is doing better than GPT 4.1, those kind of things. Evals is very, very specific to your particular business case. This has to be written per use case. Third pattern, I think all of us know, is the embedding pattern. Vector database is all of that, where we basically take large chunks of text and we kind of embed them into this sort of a dense vectors. And the good thing is that these vectors capture the semantic context of those words. So what does mean? So if I take apple as a word and I make it or embed it, I put it into an embedding sort of an algorithm, and I basically get a vector database, right, which is a semantic representation of an apple. And if I do the same thing with something like pineapple, right, which are both fruit category, so they will, those two vectors will in the multi-dimensional space be close together. Whereas if I do a embedding of something like a spaceship, it will be far. So it understands the semantic understanding. This is very important. Again, another foundation pattern is this guardrail pattern. As I told you, right, in your direct prompting pattern, you don't have guardrails, but this is very important. This is like some sort of a solution which is also LLM based. Could be LLM based like Nemo, LlamaGuard. These are LLM based guardrails where before you give something to the LLM, the final LLM, you first have to go to the guardrail. So as you can see, the query has to be first checked by the guardrail. The guardrail will say, yes, the query is okay. Only then the query will go to the actual LLM. And once the response comes, again, the guardrail will see that the response is okay. Then the response will come back to the user. So basically, between the user and the actual LLM, you have put forward this guardrail framework or guardrail LLM to ensure everybody is doing the correct thing. And you kind of avoid hallucinations, avoid security risks, prompt injections. In many ways, this is very important. So I kind of went through the foundational pattern. That is like building blocks that you need to know about. After that, we come to this concept of basic RAG. So what is RAG? Again, this is also very simple. Retrieval augmented generation is, I was telling you, right, in a direct prompt, the LLM doesn't know anything other than the knowledge base it was trained on. But what if you want to also add some contextual information on the enterprise data? So what you do, you basically take your enterprise data, you chunk it, you kind of embed it, and you store it in a vector database. So basically all of the data you have taken and you have stored it in the vector database. Once that is done, once a user request is coming, that user request also you embed it into a vector, and then you kind of compare, right, where in the data, from where in your indexed enterprise data that sort of context is available. You take that context from your enterprise data stored embedding and combine it with the user query basically, and overall you get a final sort of a query, the user query, and you get the context, extra contextual information regarding that query that is stored in the vector database. And the vector database is, as I said, a representation of your whole enterprise set, and then you pass the whole thing to an LLM, and this is what basic RAG is. Again, very simple, this is not a problem. But then basic RAG has to be might not always be enough, right? This is what you will see once you start down this journey, that basic RAG doesn't always give you the best. It's still prone to a lot of challenges, and that's where you start with some advanced RAG patterns. One of the pattern is hybrid retriever. So what you do in hybrid retriever is you don't just search via the vector database. Obviously you do that, right? The vector embedding, the basic RAG, you do that, but you also search with normal keyword or similarity based searching. You do that as well. So you pass the same query both into the vector thing, right, to get that additional context, but you also pass into your corpus of data and do a keyword based, similarity based searching. So from the vector, you get some document fragments. From the vector-based search, from the keyword-based search also, you get some document fragments. All of these document fragments you combine and you pass on to your LLM basically. So this improves the quality of your responses. Same is with this query rewriting. What happens with the query rewriting is the query that the user has taken, you use an LLM and you basically write it in multiple ways. So the same query, you put it into the LLM and you, let's say, get 3 or 4 more types of queries, right? Similar sort of queries. And then you send all of those queries to the LLM. So rather than one query getting the answer, you send 4 similar queries to the LLM and you get all of those 4 answers and then you combine them. Basically, all of this, as you can understand from some of the patterns, are trying to ensure that some of the hassles that you have or some of the inefficiencies that you have with basic RAG. If basic RAG works for you, good recovery, good accuracy, good retrieval, very awesome. But if it doesn't work, some of these advanced patterns like query rewriting, hybrid search are relatively easy to implement and has given some good level of updates. RAG re-ranker is also another advanced pattern. What happens here is that you first basically kind of using the retriever, you get the sort of fragments, right? Your context, you get those context from the retriever, right? And you do it in a very fast way, right? You kind of sort the documents by relevance using some sort of a basic retriever, and you try to find what could be out of the hundreds of chunks, what could be the important chunks. You first very quickly get them, right? Out of 100 chunks, let's say you have identified 5 chunks. Once you have identified those five chunks, then you feed it to the re-ranker model, which then very slowly, to some extent slowly, will scan through that and try to understand which of these chunks or which of these document fragments is best suited to answer your query. And then you can send, let's say, the top 3 chunks to the query. So again, you are first doing a very quick search, getting some of the, rather than doing a full sort of scan over all of the 100 chunks, you are first doing a very quick chunk search on some of the chunks, and then you are getting a little bit filtered result, filtering it to the re-ranker, and then again going through. The re-ranker is helping you understand which of these chunks are the best suited to answer your query. So if you put all of these patterns together, then you can see an advanced RAG setup that works in production. So if you see what is the step 1, the request has been sent by the user, but first we will use the foundational pattern of guardrails. The request will be handled by the guardrail. That is step 1. After that, once the request has gone through the guardrail, then the query rewriter will basically create multiple queries out of that single query, right? And then it will send them to the hybrid search sort of a system. So it will send it to keyword search and it will also send it to the vector search. To send it to the vector search, obviously the embedding will have to be done. After that, as I said, the keyword search will also happen because we are using the hybrid search pattern. So we got the multiple queries. Parallelly, we have sent them both to the vector search and to the keyword search. We have then aggregated all of the results, right? All of the results we have aggregated. But once we have aggregated, we will run it through the re-ranker model. This will ensure that all of the searches have led to a lot of results, right? Because we have first run query, rewriting all of these results we have got. Now, once we have all of those results, we will send it to the re-ranker. The re-ranker will basically understand. And finally, the re-ranker will just send, let's say, the top 3 chunks to the conversational LLM, which is our actual LLM, which will answer. The conversational LLM will answer the query based on the original query that we got and also the context we have sent via the re-ranker. And finally, it will go to the output guardrail and then it will give a result. At the same time, there is another concept I did not go through this a lot. There is a concept called fine tuning, which is where you don't send a RAG or you don't set extra context. Rather, you kind of fine tune or kind of provide the more data and retrain the model. The actual LLM becomes more intelligent or more context aware. But to be very fair, when I was working, yet I have not had a chance to play around in fine tuning, or do I need to do fine tuning? That's why if prompt engineering is enough. So this is a flowchart I just wanted to show to have an awareness of everything. So if prompt engineering is enough, then we will go through prompt engineering. If prompt engineering is not enough, we will introduce RAG, some of the advanced RAG patterns. If RAG is also not enough, only then we should do fine tuning. Okay. So again, in section 3, one of the key takeaway message is that there are different architecture patterns, starting from foundational to intermediate to RAG to even fine tuning could be thought of as an architectural pattern. And we need to understand and evaluate, and we need to spread this message about these architecture patterns across the enterprise, because these are tested patterns, these are tried patterns, these are patterns which are working. There's a lot of literature around these patterns, and we should encourage all of our architects and engineers and designers who are developing these Gen AI applications, our AI engineers, to think and invest in these patterns. In section 4, I will just, again, as I said, sprinkle a little bit on AI agents. So, because without that, you might say, okay, guys, what are about the architectural patterns of AI agents? Yes, AI agents is also important. AI agents are, I think of them as, let's say, more intelligent or autonomous sort of bots. They can perform tasks on behalf of a user, right? And they have this capacity to interact with the environment by calling this sort of function calling and tools. So basically, an agent can do stuff on your behalf. It can understand the context that you want it to do. It can respond to some extent autonomously. It is much more autonomous than just a rule-based workflow. And it has this ability of something called function calling and tools to work with the rest of the environment. So this is an input anatomy of an agent. So as you can see, you are getting the input. This is basically the LLM, and it is generating an output, but it also has a memory. It knows about what happened, and it short-term memory, long-term memory, and it also has access to tools to interact with the environment. So enterprises have already started deploying AI agents. So this was an assessment that was made by LangChain. They reached out to 1,000 survey responders, and if you see, 50% of them are saying that I am already using agents in production. So it is not about, okay, when will agents come, I will think about that. Even though most of the enterprises use cases might be solved by normal RAG, advanced RAG, those patterns, but we need to also start thinking about agents. And especially when we start to think about agents, there also we need to invest in well-defined architecture patterns, because based on surveys, we are seeing that getting an agent from a POC to production is very complicated. Same with RAG, you will see, right? Doing a simple RAG for a POC on some sort of data set, very, very easy, much easy. But going to production with it is a little bit more complicated. So here I just wanted to share a few patterns very quickly. You should go through more details in it. There's a concept of a single agent pattern. This just you give an input to the agent, it gives an output, it uses tools and all of that. That's a single agent pattern. But then you have multi-agent patterns. In a multi-agent pattern, there is this concept of a manager pattern. So what happens is that the request goes to the manager agent, and the manager agent kind of distributes the tasks between this sort of task agents. The manager is more like an orchestrator. It will orchestrate the tasks and give the result. This is a multi-agent pattern where more than one agents are starting to communicate or talk to each other. Similarly, there is a multi-agent decentralized pattern. What happens here is that you send the request to the initial sort of a agent, right, which is triaging the agent, but then that agent kind of decentralizes that request, sends it to some queue. Whichever agent is much more comfortable in understanding how it can fix that, it will basically try to take it from the take that request from the queue and start acting on it. So these are different sort of patterns for agentic AI. As I said, right, basic RAG, normal, advanced RAG, fine tuning, those are at one place. And then once you enter this realm of agentic AI, I did not focus a lot here because I wanted to first kind of cover the traditional RAG based architecture patterns in this session. But agentic AI also has a lot of different sort of patterns that you will see. As I said, right, orchestrator pattern, multi-agent pattern, reflection pattern, where one agent is kind of reflecting on the output, self-evaluation pattern. There are different things you can do with agents as well. So with all of this, I wanted to now kind of close. I went through a lot of details, right? Again, I mean, a lot of different use cases. The idea of this session is not to go through and explain each and every of these use cases, because even the query rewriter pattern, I can go on, I can share you examples of what works, what did not work, right, for 30-35 minutes just in itself. The idea here overall is that we should not be in a state where, as shown by this cartoon. This cartoon is showing, have you figured out how AI will impact our business? This guy is saying working on it, but again sending it, asking the same question to the chat GPT. No, We need to have a focused iterative approach if we want to generate credible value for our business stakeholders. And to do that, we need to start on this maturity model. On step one, we don't need to do fine tuning, multi-agent orchestrator. No, we first need to understand what the business needs. If the business requirement can be made by just a RAG, we might not need a graph RAG, not need an agentic RAG, not need any of those things, right? So it's a maturity model. This is also very important. We need to mature, but at the same time, we need to have a strong foundation based on architecture, because architecture helps, architecture pattern helps. Somebody needs to ensure that they have good architecture patterns defined within the enterprise, communicate, advocated, and the rest of the organization starts embracing or adopting those patterns. The reason why this is important is that we are today in kind of this sort of, we were initially in this chatbot phase. From there, we went to this reasoner phase. Now we are kind of in this agent phase. If we truly want to transform ourselves into an agentic first enterprise, right, we need to have all of these architecture patterns, the foundations kind of set for us. This is the last slide. Again, these are obviously, you know, all of these very, very important people, very successful people. I want to kind of share this one thing that I like from Satya Nadella. What he said is, our industry does not respect tradition, it only respects innovation, right? So this is what he said. So why I'm saying is that the industry is innovating very rapidly, but at the same time, we need to be core to our strong areas. So one of the strong areas that an enterprise will have is code good architecture practices, right? Strong architecture patterns which scale, which are tried and tested, and we need to focus on those architecture patterns. With this, I hope I was able to cover the breadth of what is happening in this enterprise AI architecture sort of a scenario. And if any of you want to reach out to me, connect with me, feel free to do so over LinkedIn. I'm very active there, and I hope you have a great rest of the conference.
Yes, thank you very much. That was deep and fun at the same time. Hello, Turja. Happy to meet you. The last minute speaker. How are you?
Yeah, I'm doing well. Thank you, Ed, for accommodating, and I hope everybody's having a great conference. At least I am having. Thank you so much.
Yes, I'm enjoying so many great stuff I heard today. Okay, tell us where you're based. How are you? I don't know. We don't know anything about you.
Yeah, so basically, I'm based out of Bangalore in India. I currently work in a Big Four consulting team as the global platform pieces lead, where I manage a very big technology platform, one of the largest technology platform in the world right now. And right now, as you understand, right, like everybody, we are also thinking about how to inject AI and Gen AI into the processes, the technology, every single layer of the platform. So that's where most of my day job is, right? So I think about what is should be the strategy of the platform, what are some of the architecture components we need to build it into the platform. Again, it's a technology platform, so on top of it other people are building applications, so we are more like the foundation. So that is what I do basically as part of my day job. And really great, again, this was a great conference. I had a good time. I was listening to many of the other talks. Tomorrow also, I know we have another stellar lineup of speakers, so great to be here.
Thank you very much. And what is Qdrun? Actually, I heard about that project a lot, and I was surprised to see you work there, because it's nice to hear for architects about that project too, I guess.
Yeah, so Quadrant, I don't work in Quadrant. So I am part of a Big Four consulting team, but I have some ambassador positions in some other organizations. So for example, because I work a lot in technology, I'm also a platform engineering ambassador. I'm part of the CNCF platforms working group, and I'm also a Quadrant star. And I also run two communities myself. One is a HashiCorp user group, and the other one is the Docker user group for my region. So I'm extremely active, so to speak, right? Even in LinkedIn, you will see that I am always posting something, writing blogs and all. So I keep myself involved in many technology events. So Quadrant is just, I'm one of the stars, but I don't have any affiliation or representation with them.
Oh, okay. I just wanted to hear about the technology.
Oh yeah, from a technology perspective, basically Quadrant is a vector database, right? So if you have followed my architecture patterns, the second architecture pattern, again it's a foundational pattern, is called embedding. So what happens in embedding is that, as you understand, right? So we have a lot of text. It can even be images, and we basically try to encode a semantic representation of the same. This is vectorization of the data. Now, where do you keep those vectors? Right, where you have to store those vectors somewhere. So this is where vector database has kind of emerged as a pattern. They roughly now have 2.7% of the overall market of databases. And I know about this because I'm actually presenting on vector databases in the Vector conference on June 6th. So I have a session there as well. I'm a speaker there. So there are two different, basically there's a lot of types, but there are two types of vector databases. In one way is standard database providers who are always there, like let's say SQL, PostgreSQL, Mongo, right? They were always there. Now they have also started offering a flavor of vector databases, right? For example, PostgreSQL has something called PG Vector, which is very, very popular, one of the most popular vector data. But then, because in this Gen AI era, there is a lot of new startups / mid-sized companies that have kind of from ground up, they have started. One of them is Quadrant. You have something called Milvus, Fize, which is funded by Facebook. Many of them, right? VV8. So they are kind of building a data structure and an ecosystem around it just for vectorization. So they're very, very focused on vectorization. They don't help with all of the others. So they don't help with relational database. They don't help with NoSQL. They are very, very focused on vector. So that's why many now that is actually the topic of my discussion on talk on 6 June is when do you choose what? Should you go ahead with Mongo because it's already there in your system maybe, or should you go with PostgreSQL, or should you invest time and effort in going with a new vendor like Pinecone, Milvus, Quadrant? So basically that is what. So I have used personally Quadrant in some of my POCs. It's a very, very simple, easy to use sort of offering. But most of this are, it's not only Quadrant, most of these new age vendor projects are very, very easy to use. They're very cloud native, so to speak. They were built ground up for Gen AI, essentially. So that is the difference.
Okay. Thank you for brief introduction on vector database. I have some issues with the platform right now. I can see. Just okay. Now we see. Okay, we have the first question related to your presentation. How do you handle versioning in advanced RAG setups when enterprise documents change often?
Yes. So again, I mean, it's in itself is a complicated sort of a. So I will tell you, at least when we started, right, in many of those cases, especially when you don't have a lot of scale, for example, the first setup that I did, I just ran the entire pipeline every night, and that worked as well. So rather than thinking of that delta, right, because it's not only new documents which are getting added, right? It could even be existing documents that are now getting updated. So the moment an existing document gets updated, you might even have to, obviously not even might, right? And again, it all depends upon how much accuracy or relevancy of the retriever you are okay with. As I said, it's all a perspective, right? So as I said, if for very, very simple applications, we have just run the pipeline every night. So for example, we used to work on something where it is a lot of data and we used to store all of those data, basically documents as JSON in Mongo. So I had an ingestion pipeline that every night it will run as if from scratch, right? It will take the entire thing, then it will put it into, again, not the most efficient as you can understand, but kind of quick and dirty. You really don't need to think about a lot of complexity and manageability. But then once you move forward, then again, there are advanced patterns where some of the new vector databases can also kind of understand when something has changed. But one of the patterns we were doing is, let's say, for example, we are keeping an index, and whenever something is changing, you understand which is the chunk, right? where it is affected. But there also there is a lot of complexity, because in some of the chunking models, we just don't chunk that document in discrete chunks. What do I mean by that? It's not like, let's say you have a 5-page document, and let's say you are doing, I'm just making an example, let's say you are chunking per page. It's not always the best option, right? Sometimes you will know we will have to have an overlap between the chunks as well, right? So the first document, let's say you do a chunk 1, then the chunk 2 is, let's say, 50% of the first document, 50% of the second document, and then chunk 3 is the second page, right? Then just imagine, right? Then the same part is in 3 chunks now. So you now have to go in and update. So again, I mean, there are some good literature around it that you can do, but it's a little tiresome, so to speak, right? It's not a very easy method. It's a little tiresome. You basically will have to identify the portions of your, let's say, affected knowledge base which are being changed, and then the new ones is okay. Whenever a new document is getting updated, it is still okay, right? You just run a delta ingestion pipeline and it works. So it's not a very problematic situation. At least in our use case, whenever something new was getting added, we used to get an event hub in our Kafka and we could understand that. But whenever it is the existing ones, it's very complicated. You have to have some sort of a mapping between your chunk. Let's say you have a hash table with, okay, this is chunk 151. This is the start document ID. This starts from this word or this character in this page to this character in this page. So the moment something within that thing has changed, you know which are the chunks affected. So something like that you will have to do. It's a little complicated.
Right. Thank you very much. And moving on, when using re-rankers, how do you balance latency and quality under real-time constraints?
See, again, as I said, right, I mean, I think it is one of the biggest problems in all of the everything, right? Whether it is RAG is, if you see most of these LLMs, right, the inference engine that is running, typically, I think they run, I don't know, like 1 second, they can process 1,000 prompts, or I forgot the number, right, in that way. When we are doing a ChatGPT is okay, right? Because ChatGPT is a B2C product, right? You really don't care even if the answer a split second later. Who really cares, right? But the moment you are using it in some sort of a real-time application, the latency is obviously like a very complicated problem. And all of these advanced RAG patterns add latency and also at cost. Not only latency, it also adds cost. Because now you are again sending it to another, again you will consume tokens, right? So all of that's what I'm saying, right? It's very important. And we have spoken to OpenAI, right? So they also kind of told us that, guys, go back to the basics. First, do good evals. People don't focus on that much, but I have learned the hard way. I think that is the most important part of the entire stack. Once you have a good eval, that's when you really try to understand that this extra latency and extra cost, is it really worth it? If your business is okay with the kind of data you are getting, right, and they're okay with a little bit of, let's say, not completely accurate, because they know, right, okay, at least you are able to point them to the page and then they can do their stuff, right? So then they might be okay with it. You don't need to do hybrid search. You don't need to do advanced RAG patterns like query rewriting, re-ranking, right? But if you do that, yes, there is a chance. That's something, right? Always set up. That's why I said eval is a foundational pattern in my mind.
Right.
I first do the eval, then I put the thing through it, and then I iteratively kind of see, okay, I have added this re-ranking. Has it really improved my if my accuracy was already 90-95%? Some documents have that accuracy. You really don't need to do a lot. By basic, you have 95% accuracy sometimes. So in that case, it is okay. I might not even need to do some of those advanced patterns, because every single advanced pattern will have some latency and it will have some. And last thing I will say is that now there are some inference providers. For example, there is something called Grok that has now come up, right? And they have optimized that inference engine so much. They are much more faster than the OpenAI. So I think they are giving prompts at 100 times or 50 times faster, processing prompts per second, 50 to 100 times faster than OpenAI prompts, right? Processes them. So those kind of things also you can think of, right? If I can change my inference provider so that my latency per prompt improves, then even if I add another 2 to 3 layers in my architecture to improve my accuracy, still my latency will be manageable because I have just fixed it at the core, right? So
Right.
that could be
Right.
interesting.
And next question. What's been your biggest security challenge integrating LM guardrails in production?
So what I will say, I would actually say that guardrails we have implemented to avoid security challenges, to be very fair, right? That was my approach. Uh, so in most of the enterprise applications, you will see before something can go live, there is some sort of a quality process, right? Enterprises will just not let you go live with a chatbot so that anybody can start asking it, okay, how to make bombs or whatever, right? That's not how enterprises work, right? Obviously, now more and more you will see many of these models have also intrinsically become much better. So initially, when this model started 1 year, 1.5 year back, you could ask them some weird questions and they will come up with some weird answers. Now, if you ask the same weird question, it does not give that sort of a weird answer. But again, no matter what the LLM is doing, right? Let's say the LLM is the best LLM, still an enterprise will not trust just that LLM. They will want some. So there will be some sort of a QRM, quality risk management process, right? Some sort of a change acceptance board who will approve your production application only when you have some sort of a guardrail. The only thing with those guardrails, as I said, is some of those guardrails are kind of will add a little bit of latency and cost. That is anyways there, but they're very easy to integrate. Mostly, for example, I have worked with Nemo guardrails from NVIDIA, very easy to integrate. Only thing sometimes is that some people are now saying that, but that's like a very, very rare proportion, I feel, is that guardrail might object to something which you actually want it to accept. So now people are saying we need to fine tune that guardrail model itself to make it more. So for example, let's say you are building a website where you want people to, let's say, communicate with each other in a very, let's say, not in a very formal manner, where a friend might be talking to another friend and saying something very weird, let's say, right? Now, if you have some of these guardrails, they might block that session or not. So that could be something, but I don't think that is an enterprise challenge. In enterprise, most of this out-of-the-box solution will work quite well.
Right. Thank you very much. And last one, in practice, how do you decide between investing in fine-tuning with stacking more RAG layers when accuracy is lacking?
So again, I think it's complicated. As I said, right, again, all of this goes down to the evaluation. But I will, in my mind, if you see, right, normally, let's say I'm not an ML expert, right? I don't understand feature management and all of those, right? Attention, algorithm, all of those. I don't understand that much. I know high level the concept of transformers, but I have not. So, but I can still build a RAG application, as can my team of 100 developers, right? They can, because as somebody was saying, right, in one of the summits, not this one, some other one, that every AI application is basically an integration problem, right? So the moment your AI or LLM or hosted inference provider is exposing an API, right, essentially you're just calling an API, right? And then you work with it. So RAG to me is easy to understand as a developer, even if I don't kind of know the basics of ML. Whereas fine tuning, from my perspective, I've not done it myself, but I have felt that it needs a little bit more knowledge in, even though it's not like you're building the entire LLM. It's not like, obviously now the fine tuning, it's like you can provide a little bit more data and it can still do. But I think that's where you have to understand a little bit more ML. So that's why it all depends upon the team and your proficiency. From our perspective, for most of the majority of the enterprise grade knowledge management solutions, let's call it knowledge management, where you have a lot of good documents and you are kind of getting it, the solution from there, I think RAG for us was okay. Fine tuning, now we are actually delving into fine tuning, but that's a different sort of a approach, right? We are doing fine tuning for more like domain specific agents. So now we want to publish, let's say I want to publish a tax agent, I want to publish a healthcare agent, right? I want to train it on all of the data. I cannot afford all of that latency. Every time I'm talking to that agent, I cannot afford the latency of going to the chunk, getting the data and all, because I'm not only using it for knowledge management. For knowledge management, I might be okay when I'm asking a query. the query goes, embedding, everything is happening, I'm getting the answer, I'm okay to wait. But now when a multi-agent system is working in the background, another thing is also for multi-agent systems, when the agents start chattering with each other, it's a lot of prompts, right? Now, if every time an agent is talking to another agent, and now the second agent has to go back and get all of that, it's not only latency, it's also money, as simply speaking, right? So if you can invest some of the money initially in fine-tuning the model, then you can sometimes even save a lot of the money in extra prompts. You can save on the latency. So again, as I said, right, it's a case-to-case basis. I don't normally see enterprise knowledge management solutions, chatbots, most of the stuff that enterprises normally do with GenAI. I really don't think there is a need. At least I have not felt a need for anything other than RAG. But when you are going into this era of domain agents, where you want that the agent itself is a business enabler for you, you want multiple agents to autonomously work together and give a business value, then maybe it's a different story in my mind.
Thank you very much. I admire your deep expertise in understanding both technology and strategy, and maybe even the product part. Thank you very much for being with us today. And yeah, I definitely would love to speak with you about CTO Global Summit, because I feel like you have deep expertise in strategy of AI products, and this summit is all about AI in SDLC as productivity tools and AI in our products. So yes, and all right. Thank you very much for joining us today.
Thank you so much. Thank you again for accommodating me at the last moment, and thank you everybody. Great sessions and great conference.
Thank you very much. Okay, ladies and gentlemen, this is the end of the day one. We had amazing topics, some real nice fun, and real deep knowledge. So tomorrow is an AI day. We'll hear a lot more about AI than today. And still, if you don't have any tickets for tomorrow, you unfortunately will have no recordings also. So I encourage you to use this promo code to just buy a ticket for tomorrow's sessions, and or chat in the online chat with Vicky. She might give you even bigger discount. So see you tomorrow. We'll have let me see. We'll have like, yes, 9 speakers tomorrow. Let me just share. If you don't have it next to you, I will share the agenda right with you here to announce what we'll have. And yeah, so tomorrow Sergey Sokolenko from Tower will be speaking about local development serverless production with DeepSeek R1. And then David from Next will be speaking about monitoring business metrics. Then Christian will be speaking about implementing enterprise data bus with Microsoft Azure. Also, we'll hear from Bibian Ephemeral Jenkins with AWS. Varun Jar from Deloitte will be speaking about generative AI, an innovative companion for software architects. Dia Chadra from Synopsys, proactive Gen AI tools for software architecture. And 3 last speakers, Rohan will be speaking about scaling and optimizing enterprise app. Vibhas will be speaking why Yagni matters in software architecture. The last one, Naga Santosh, or Sunny Quader as we know him, Model Context Protocol, why it's a game changer in building intelligent applications. So lots of stuff for tomorrow. I can't wait to hear all that. And yeah, and that's probably it. Thank you very much, and see you tomorrow.